I gave it to select people to try.
Yeah.
I gave it to this nurse practitioner that I know really, really well, and she was like, "Oh my gosh!" She's all like, "I have the best skin I've ever had." She was all like,
You are listening to And If Love Remains,
Speak peace like a Buddhist.
a unique show spotlighting people, ideas, science, culture, and art. Your host, Mike Leavitt.
Hello, Rachel. Yes, you are listening to that great podcast, In the Sky and If Love Remains, and I am your host, Mike Leavitt. I'm the messenger of the great podcast that we all know and love. I hope you guys will subscribe, listen, share, all that good stuff. Make this thing viral. Do that thing you do. You know what I'm talking about? I am very excited to again have a good friend of the program, returning guest, Will Bozeman.
Thank you very much.
Hey, it's good to have you back, man. I got some great response from our last show. I really enjoyed the conversation, and I lots of people were listening to the clips and were checking it out. So I wanted to bring you back on, and I appreciate the opportunity to do that and talk about some things that I think as a layman, first of all, Will Bozeman, health expert, longevity expert. Name the companies that you're involved with. What are some of the stuff that you're doing? Give us a quick CV.
Sure. So Relative.com. That's my longevity platform. That's RELATYV.com. I've got LongevityStemCells.com. That is a stem cell banking lab program for people. I've got Regen Aesthetics.com, which is a regenerative aesthetics skincare line using we can talk about that later.
Yeah.
But it's got unique products, stuff that's patented, things like that you can't get anywhere else. And then I've got some completely non-medical businesses that I manage as well, or that I own and operate. But I can jump into those later if you want.
Yeah,
but, I could talk forever.
all around entrepreneur, good guy. That's great, man. That's cool. I'm very interested in the state of kind of health science. I'm getting to be where I can call myself an old man now. and so longevity matters to me more than it did 10 years ago, I guess. But also things have changed so much. I remember maybe, 5 or 10 years ago, I started hearing, I still don't understand it quite directly, but I started hearing about things like the CRISPR stuff, where they were messing with DNA and stuff like that. That seems to have it doesn't seem to be quite a hot topic. Maybe it is. I'm just not seeing it. And then, but before that, it was all about vitamins and, different, in fact, I remember a time when many people thought vitamins were just a hoax, and maybe they were because of how they were produced. I don't know. But I think it's such a fascinating thing as we attempt to do the most with what we got,
Well, yeah, absolutely. Did you ever watch I Love Lucy?
Sure, yeah.
Do you remember the episode of Vitamin?
Oh my gosh.
Yeah. So every time somebody talks about vitamins being a iffy thing, I'm always go back to oh yeah, I remember even back in the 50s they had Vitamin,
right.
Trying to sell a product, So CRISPR techniques.
Yeah.
So this is I told you in the last episode I was on. My background's in biotech. I did my undergrad in biotech and another one in archeology. We talked about that.
Oh, that's right. Yeah,
So
that's right.
Got a couple more.
We got to talk some archaeology sometime, by the way.
We'll talk today. Yeah, I've actually been digging into that lately too.
No way. That's cool.
Yeah. If you can, with the way my mind operates, I can typically do a couple things at the same time. But anyways, aside from that, I was actually just explaining this to my kids literally yesterday.
Okay.
On how genetics works, because they were asking about different varieties of fruit. How is it that we have this one fruit and it's so different from another one that's the same kind?
Right.
Same variety.
like a Granny Smith apple versus a ruby red apple.
Yeah,
You know, that
actually, it was apples we're talking about because the kids like pink lady apples.
Okay, yeah.
And they're like, Dad, what's the original apple? And I'm all like, okay, you going religious here? The original apple of the tree, or are you talking about what's the original apple? You know, that grows in the ground. I'm like, that's a very hard question. I can tell you what the original corn, you know, maize corn kernel was. It's the teosinte plant in Central America. It grows like a little, you know, grassy kind of weed, and it puts out is 2 or 3 grains at the top of the head, and that's the original corn. That's what I can identify that our modern day gigantic ear of corn descended, you know, through all sorts of work.
Yeah.
From that little teosinte plant, right? So, and so there's things like that. And I was explaining to the kids, like, I'm not really sure which apple was the original. It's like traditionally in the United States, you got a Red Delicious apple that everyone hates.
Right.
But have you ever had a fresh Red Delicious apple off a tree?
I don't think I
There's
have.
a reason they're called Red Delicious apples. They're completely amazing. Right off a tree, they are so sweet and so crisp. It's the storage and processing and shipping process that makes them crappy.
Yeah.
You know, but right off the tree, oh man, they're amazing. So I lived up in Washington State. I did a mission up there, and I lived in the apple orchards. I lived in Selah, Washington for a while, and Selah is where treetop apple plant is.
Okay.
Right there. I see the treetop plant right across from my apartment. Anyways, I digress here. So varieties of apples. Yeah, green ones, large ones, Granny Smiths, and the Honeycrisp only came out a few years ago, and it's like the most popular one.
Yeah.
So how
and
is
they are so different. Like it's interesting. Like you would use certain apples, you know, for example, a pie.
Right.
You know, where you would never use like a Red Delicious apple for a pie. I mean, that's not like the right kind.
Exactly. Right. So so you're right. All these different varieties. So what's the original one? The kids asked. I'm like, well, that is such a can of worms question, guys. Do you really want to? It's a joke. Oh my gosh, Dad's gonna start talking about science, and then we'll never get out of here. Or archaeology, never get out of here.
Yeah.
Or other things that I love to study, like the Holy Grail is another topic.
Oh,
Don't get
yeah.
me started. I should have a whole podcast on the Holy Grail.
That's great.
And they know not to ask certain questions. And one time, Dad, can I ask a question, but I don't want a big long answer. I'm all like, well, depends on the question, you know. I can't just answer it and leave you hanging. That's
Right.
irresponsible, you know. But so
Long answer yes with a if. Short answer no with a but.
yeah, pretty much. I mean, but I can't. It's if I know it and I don't tell them, then they won't know it.
Yeah.
I joke all the time. I'm like, guys, I'm about to tell you something that your teacher won't understand either. So if you raise your hand in class and tell them that you know this, your teacher's going to just stare at you blankly. I explained like just.
And your kids are in college, right?
Yeah, seriously, kids are 7. He just turned 7.
Yeah.
So 7, 9, and 11 are my
Okay.
3 kids, and yeah. They're college level problems already. You
For
know?
sure.
But maybe not. I shouldn't say that. There's plenty of people that could speak to their gigantic problems with kids as they grow up. But the question: what's the original apple? Right. So I'm talking about varieties. Going to Mendelssohn and his genetics, right? The pea plants and all the things, and talking about breeding using the different plants and selecting out, right? So I'm like, it's a process of horticulture is a process of identifying the plants you want, growing them out. There's 2 ways to do that. You can select and rebreed and the plants and get what you want. And that takes years and years and years, decades to create a variety, right? Where you can regrow the same plant over and over and over and over and have it be that variety, right? Or you could just genetically alter it. Interestingly enough, the process, the result is practically the same. So a lot of people are like, oh, GMOs. Right. You could do a whole podcast episode on GMOs with me if you want. And I'll explain to everyone that it's not the big bad guy they think. What they've been told about GMOs being so terrible is why they were created, for the purpose of being able to resist certain pesticides. That's what makes GMO so dangerous. Right. So I don't want to name names here, but there's some company. I mean, well, I'll just, everybody knows Roundup. Roundup's the big one, right?
Sure,
So you Roundup kills everything.
Yeah.
And I love gardening my whole life. So you spray a plant with Roundup and it dies.
Right.
Awesome. I can spray this weed and it'll die, right? And get it right out of my yard, out of my garden, right? Now, what if you took that and sprayed it over a whole crop of fields? Well, everything would die unless you genetically alter your plant to resist the Roundup or the glyphosate that's in the Roundup that kills them. Okay, awesome. Well, now you can use that as a gigantic weed killing machine.
Right. Now it becomes way more efficient. That's the idea, right?
So now you can grow a field of crops, and traditionally you might lose X percent of yield due to weeds, and you just can't afford to go out and pick a billion weeds.
Right.
Right. So you just take the loss and harvest what happens. Or you could buy this genetically modified seed, and then you can spray your field, kill all the weeds except for the corn or except for the wheat.
Yeah.
Right. And then it grows perfectly. And then you have this tremendously higher yield because you don't have all this, nutrient competition with all the weeds. So that's why genetically modified, plants are so bad for us. And I kind of want to, I could write a book on this and have a picture where which plant would you want to eat? And it's this big, pretty healthy plant or this little shriveled dead one, right next to it. Like, which one would you eat? Right. And the joke is they are identical.
Yeah.
It's just that this one resists the glyphosate. But it doesn't get rid of it. It still has it. So whatever killed this plant, we wouldn't eat the dead gross one.
That's
right?
fascinating, man.
The dead gross one sitting here, rot, shriveled and rotten. You would not put that in your mouth, but you are putting that in your mouth because this one over here still has the chemical on it.
It's still pretty.
It just still is alive.
Well, and by the way, now it's kind of my question when it comes to that, and I think we could talk about altering things genetically all the way around. But like, to me, I just have one of my core foundational principles is that there's trade-offs with everything. Like, you're never gonna get something for nothing, right? And so the trade-off, one of the trade-offs is you get this beautiful plant, but you still, it's kind of like, hey, I'm gonna go. Hey, the oil light in my car is on. I need to go take care of that. And you clip the wire to the oil light. And said, "Oh, okay, it's now
taken care of now.
It's not the oil light's gone."
Or I guess on Big Bang Theory, where Penny would put the sticker over the check engine light.
Right.
That's how she fixes it.
Right. Exactly.
I would fine just put the sticker over it. And Sheldon's always freaking out about that. But so the reality is if you didn't spray the crops with glyphosate, then that plant that was genetically modified is actually perfectly fine. There's nothing wrong with it. There's nothing that's going to harm you in it.
It's the fact that you sprayed it.
It's covered in chemicals. It can resist the chemicals, right? So this is a notorious fact about plants is that they absorb everything. They're sponges.
Right.
Right. Matter of fact, I think I mentioned this before, but maybe it was you, somebody else. There's a company, one of my biotech friends went to go work for this company. They design rapidly absorbing plants to assist in industrial waste and chemical spills and cleanups.
That makes sense.
So they actually design plants that will grow in the soil that's been tainted, and then they harvest those plants and they dispose of them like industrial waste.
Wow, that's insane.
So imagine if you ate that plant.
Right.
It's filled with industrial pollutants and waste and particles.
Right.
It would kill most other plants, but these have been genetically modified to be able to resist that, so it can suck up all the nutrients.
So they're a wonderful,
suck up all the pollutants.
Right. So they're a wonderful tool for what they do.
Exactly. It's a tool for what it does, but if it's used the wrong way, it can harm you. That exact same plant is also perfectly harmless to you and practically could be good for you if you were to plant it in a regular garden and it didn't absorb all the pollutants. So, I mean, that's genetically modified. So anyways, going back to the story of what's the first apple, you could either alter it over time using genetics. And when you do select out the genetics, if you were to do a study on the genetic profile, it would be quote unquote missing the genes that made it look this other way or taste this other way.
Okay.
Because what you have is this now. Or you could simply just cut that out in one fell swoop, and you can save 10 years of selection and horticultural work to get to this one variety, and now make a whole new variety in less than 6 months.
So, like, I think about this, and again, this is kind of how my brain works. For example, like artificial diamonds, right? Like, it's hilarious to me. I don't understand why, but you have like natural diamonds and artificial diamonds, and natural diamonds are always way more expensive, but the chemical composition, like everything about them should be identical, right?
It is. And I was talking to somebody the other day about how the diamond market has gone to great lengths to try and equivocate the natural, the artificial diamonds to natural diamond value.
Right.
When the reality is you can make them for hundredths of the cost.
Right.
You know, so this 1 carat diamond you could buy in industrial setting.
There's
for
another
$100.
rabbit hole that we should.
I know. I won't go into that, but like it's identical. It's identical, but in order to keep the market and the industry from collapsing, they're trying to make them equivocal in value.
Right.
But that being said, the same principle here. You've got these plants that are identical to each other, just missing one of the genes, and so that's how you do it. Now, going back to your original comment, you know, human longevity and CRISPR, right? Could you alter a human's DNA and create a completely unique, different human that can do different things? Well, you sure could.
Right.
It's definitely unethical to do that, but you can. And CRISPR, the technology there. So that we studied that. It was at the end of my biotech program. It was becoming prominent. A few years after I graduated from my program, somebody claimed to have fully replicated the first human against all international ethical regulations. He did it on purpose, knowing he was going to be reprimanded. He just wanted to be the first one to do it.
Right.
Even in his negative notoriety, he's still in the history books.
Right.
So he knew what he was doing.
Yeah.
He's like, I'm just going to do it.
Course,
I'm going to go for this. Right.
Yeah.
So he's the first person to ever have done it officially.
And what does that look like? I can't imagine what that even like.
It's been so long since I read about it.
Yeah.
But he basically truly cloned and replicated the first human embryo. Wow. Like, but humans were off limits for all of that. But he did it and published it, and he got.
Which means that I mean, I'm sure it's been done with other animals.
It's been done with tons of animals, and me and most people I know think it's absolutely been done.
Yeah. Dozens
or if not hundreds of times without being published.
Right.
Like for humans, like unethical, sure. People are doing it, sure.
Yeah.
There's hundreds and hundreds of labs out there that are not operating under strict international regulations.
Yeah.
If you have some outside funding, you could create a lab and do whatever you want.
Or some U.S. government funding.
Or U.S. government funding.
They seem to like to mess with stuff off the books.
It's true. You don't need any secret money. You just actually
just get a grant from the
get a grant, right? And then you can build whatever you want, right? Man, that's a whole other topic. Right. I don't want to get into conspiracies at all on that, but the reality is that you could make some really interesting things in the world of biotech. I told the kids last night too that we used the glow gene that we isolated from a jellyfish,
right,
to put into bacteria, so that when the bacteria, if we wanted to know if we're inserting a new gene into a bacteria, how do we know if it uptook the gene and
turns on
and now we can visually see if it did. So that's what you do. So you take the glow gene and you attach it to the gene that you want. Right. The glow gene just becomes a tag. It's just a tag at that point. And I've done this 100 times. All right. So we just take the glow gene, stick it onto the gene we want. Let's just say the gene, go back to health and medical.
Yeah.
We use this process to make insulin, right? And we grow insulin in bacteria, right? We grow it in E. coli. Don't get scared though, it's cleaned. But E. coli are some of the simplest bacteria.
That's why I hear that. That's why it's good to study and use. Yeah.
And there's 1,000 varieties, right? Maybe more. But the bad ones, they don't use the bad ones in the lab that I'm aware of. They use different versions of them that are very, very, very simple. They're basically bioengines. They are probably the easiest, most reliable bioengines that we have. So they're excellent for growing stuff. You can grow pretty much anything you want in an E. coli. The risk is that what you're growing could kill it. Right? If you're growing a dangerous protein, a poisonous protein, it'll still replicate it. But when you put it out and it exits the cell, whatever that is could be, poisonous or harmful to the bacteria and end up killing it. So you only get so much yield before the bacteria die, but you can still do it.
Right.
Insulin's the same way. They'll actually just grow insulin up to a certain point harvest out all the fluid, kill all the bacteria, spin it out, clean it out, sterilize it.
It is.
You got insulin. They used to get it from pigs. Don't do that anymore. Now it's all just human. It's human genetically grown, but in bacteria. And by the way, I dominated that category in med school when they were talking about all that. And no one knew how this was. No one knew how this was made, right? I mean, the MCAT. When I took the MCAT, biotech was just becoming more standardized in medicine.
Yeah.
And they had a whole section, like 20 questions on biotech. I got every single one of them right. Right. It's probably what carried me in
we know what you're passionate about.
Well, it probably carried me to do decently. I say decently. MCAT's not terrific, but
yeah,
it carried me enough to get me into med school. Right. Probably the biotech section alone. Right.
Right.
Because I sure didn't get it on my OChem section. So, But the biotech section alone got me probably into med school. But that being said, in med school, everyone I talked to didn't even understand how this worked. But anyways, going back to the glow gene, we can see, if we want to make a certain protein, stick the glow gene on that gene, and now we can actually see under a light if it's actually working. All right. And that's how you can test any gene you want to see if the bacteria actually absorbed it and if they are replicating it. Because it will only work once they replicate it.
Right. Okay. And we're talking about like an apple and getting different varieties of apple.
Sure.
So I guess in theory you could take, obviously like a simple one is you could take, a cat and have it have, brown fur versus black. You can,
right.
Those kinds of like, that seems like that would be simple.
I mean, compared to bacteria, it's extremely complex, right? Bacteria are so simple. We can do this kind of stuff. I mean, I learned how to do bacterial genetic alterations and manipulations in my first year.
In fact, let me ask you this. Like, so you're able to do this stuff with E. coli bacteria. How does that translate into,
the humans?
Yeah.
So here's this. We're going right back to the CRISPR, right?
Right.
The first thing you mentioned. The technique for how you splice and how you slice and dice and splice the DNA, that applies directly to any DNA alteration.
Okay.
So we learn how to do it by testing it on E. coli and any bacteria, testing on bacteria, but we can take the same principles we learn from that and we can make them work for mammals.
That's so fascinating to me, like how that can be done so precisely.
So, okay, good question. Everyone asks that question. How do they know? Well, okay. Everybody knows the ATGC DNA, right? As the 4 base pair. You ever seen Jurassic Park? Everybody knows the 4 base pairs,
right?
In your blood, right? It's the DNA, Mr. DNA, and it's all like, it's awesome. I couldn't help it. I love that movie.
It's great.
Yeah, but it's like, this is so right. Are those people automatrons? Like, no. Oh my gosh. So everybody knows we have 4 base pairs. And DNA is so complex because the alteration and the DNA are attached to one across from each other, the opposite one, the A to T and G to C.
Right. So it's complex because, like, for example, like a computer is binary. Right. So you have it's ones and zeros, and however many bits you have, it's all going to be ones and zeros. Where DNA, it's that times 4 over a lot bigger bit system.
Essentially, yeah. And what's interesting is that when you get into, so it's so funny. People are like, how amazing life really is. Yeah. You could use genetic configurations to store data, and which is what we do. Right. That's what life does. But when researchers and scientists figured out how they could actually input data into a genetic data storage model, they realized how vast it was. It is the most efficient, it's probably the most efficient data storage model ever conceived. Which is it can fit so much stuff in. It's so amazing.
Wow.
And so
are you familiar with Stephen Meyer's work with the I forget he wrote a book. Basically, he has a hypothesis about DNA or genes being a language, and how that it's that is a sign, I guess I should say, that that we were made and created, that we were, that evolution it would be very difficult for evolution to create, a system that
I've heard tons of these kind of conversations, comments, thoughts, theories, and obviously spirituality, religion, and God. It's hard for regular scientists to incorporate those concepts, but then again, they can only go so far before they have to ask God for some help, because some of the stuff that they come up to a wall, and they can't really go any further. They don't understand why. Yeah. Right. So there's great people in history who have commented on this. Einstein's most famous one, when he references his belief in a higher being and belief in God being because of his in-depth thoughts and knowledge on the universe and the stuff that he theorized took him, you would think, to a mid-level scientist, that more knowledge would make him more understanding of science and the universe, less reliant on God. But then the people who have gone the farthest in it become more reliant on God. As the foundational theory for how everything works, because the more this is one of my favorite quotes from I thought of this when I was like in high school. I've used it ever since. And I've heard it from a lot of people ever since. Yeah. But the more you know, the more you need to know. Yeah. Right. So the more you understand how much you don't know. Right. Right. And so it makes sense. The greater achievement you reach in knowledge and intellect, the more likely you are to believe that you don't know anything. Right. Right. Because you can see so much higher. So it's kind of like climbing a peak. If you're on the side of a mountain, you can see so far, and you think you know what you're doing. And you think, if I keep going off this mountain, I'm going to see everything. Yeah. Right. And you keep going up and up and up and up. When here we're on Earth in this little theory here, this little scenario. Yeah. You get on Earth, and you can see as far as you can see into the horizon. And then that's as far as you can see. Right. But that's as far as you can go. You're on top of the mountain, and the horizon's as far as you can see. Well, what's on the other side of it? Well, that's not your call. Yeah. Right. And there's nothing you can do to get there.
That's a great.
Unless you have somebody else's help and insight to see it. Someone else who could somehow go higher than you have on this mountain, right? And the mountain's only so tall, right? So I mean, it's not like being one inch taller is going to get you any further. So I mean, it's interesting, but
there's a great quote. I think it's Heisenberg. I'd have to think about that. And I've read it recently. But it's basically it says something like every science student goes in as an atheist, and at the bottom of the what's it called, the basin, they'll find God. Oh, yeah. Something to that effect.
It's interesting. I've met a lot of people, they came from a religious background and were proud to get away from it, right, because of their science and intellect. Yeah. Only to, if they actually pursued it,
and this is a problem
they would come back around to it eventually. I've seen that happen many times with people. Yeah.
I think that's a problem with religion in general, is that it's not a God problem. And it's not a religion as it is problem, but it's how we're taught it for so many years is we are taught so often to turn our brains off. And I don't mean like faith alone kind of stuff, but like when somebody's actually inquiring, we tend to have pat answers, or we tend to say things that are kind of ridiculous, and it turns people who are smart, those kind of people off often.
So glad you brought that up. So we'll get back to CRISPR in a second. Yeah. But real quick though, my mom actually had that same problem. One of the things that turned her off, she grew up in going to a specific church in the South, right? One of the things that turned her off from continuing to go to that church is that when she asked the pastor or preacher, whomever was in charge, she asked him a question, and he told her point blank that she shouldn't ask those kinds of questions. Right. Like, she was being instructed not to think, instructed not to ask questions. That will definitely make people question. So, I don't like the idea that everyone beats up on religion as being a way to, for people to be stupid or something like that, right. Oh yeah, religious nuts and all that kind of stuff. I don't like that either, because I know so many people who are very faithful and very religious who are highly intelligent. Yeah. So it's like, I don't see I see those people that they're talking about, but not everyone's like that.
Well, and somehow they're able to work these things out, whether in their own mind or through study.
Right.
They're able to work this stuff out.
Right. But if you come across a leader of a church, even just a small, congregation, and you're telling them, don't think, don't ask questions, don't ask God questions.
Right.
And this was probably back when my mom was young. So back then it was probably more common for a local church leader to not want them
Well,
to
it's
question,
because they don't know.
Because they don't know. Yeah, they don't know. So they say, don't ask me questions because I don't know and I don't want to look stupid. So,
right.
I actually was just interviewing with someone recently about this very topic called, you ever heard of a book called The Structure of Scientific Revolutions?
No.
Okay. Read the book.
Okay.
Everyone listening should look into it. You have heard of the concept now through some modern day, I say modern day, or recent writers and thinkers and voices, but none of them conceived of this theory. This is something that was put forth years and years ago, decades ago, as a scientific theory. Basically, people have to die for new theories to be accepted and innovated or integrated into society, and that the people who created one theory or idea or something are that they built their metaphorical house on that. So if something new comes along that's better or circumvents them or basically sidelines them, they don't want that to come to light. They don't want that to be the new thing that surpasses them and their achievement. So they will actively hold it back, actively denigrate it, diminish it, lower it, keep that person suppressed, literally keeping someone suppressed from achieving academic standing so that their theory and ideas can't get, now with social media, it's a lot harder to do that. Someone could have come up with a great scientific thing,
but you still have the dogmatic. I mean, you still
got the people in charge, right? The guy who
you'll have a cult following, but that's how you're going to be seen.
Right. Yeah, exactly. If you're in the medical institutions, right. I tell people medicine's a big ship, right? It's a gigantic ship. It takes a lot of effort and energy to turn, right? It takes a long time to turn, right? So, how many doctors and people have built their entire career off of promoting a specific idea, theory, treatment, protocol, procedure, only to have the newer, greater, innovative things come along, and you ask them, what are your thoughts on that? And they don't have any thoughts on that because they didn't come up with it.
Right.
And they don't want any thoughts on that because it makes their...
It may blow up their worldview.
Exactly. Well, think about this for a second. If I had a treatment that could avoid a certain surgery, and you built your entire career refining that surgery, just like Ford and the Model T. Right. You ask the patient what they want, or ask a customer what they want. They say a faster horse. Right. You ask a doctor what he wants with this one surgery. Say, I'd like a better tool to do this part of the surgery better. He's not even thinking about maybe there's something that can avoid the surgery because he is the skill that provides the surgery. Why would he ever want anything that takes away from him? Yep. Right. So, you remember in the last episode I told you about I was developing a product for rapid tissue regeneration?
Absolutely, I remember that. Yeah.
Moving it forward, it's great. I'm probably one step or two away from getting it into the application into the FDA.
That's exciting.
It's exciting. I need money for that. Anybody's listening, has got some money and wants to throw into it. I'm trying to get anyways. Okay.
By the way, listen to that last episode because it sounded like it could be world changing. It's very cool stuff.
I've got two different ventures I'm moving forward in that category, but the one is a rapid tissue regeneration material that we have to register it like a device. Right. But I was interviewing a doctor to be the medical director for that company. And this is in the wound care space. So we're talking about, non-healing ulcers and tissues and things like that. So those are very, very expensive patients, right? To Medicare or to insurances. Those patients cost a lot. He told me point blank that a non-healing diabetic ulcer on a patient could cost Medicare, could generate as much as $250,000 over 8 weeks of revenue to the
8 weeks
over 8 weeks of treatment on an unhealing ulcer. A wound care doctor could bill Medicare for upwards of $200,000+ of services, including materials, treatment, some really expensive amniotic membranes that are the kind of the latest and greatest thing. Right. And so this material I have may very well heal up. And by the way, the reason why that is is get multiple applications of that membrane material. The membrane is very expensive, right? There's all sorts of stuff that go into that. So 8 weeks or 12 weeks of application and treatment for this one patient costing Medicare, $250,000 to the doctor who's doing it. And they make great money. Just wound care is a big field right now. It's if you look it up, it's $50-something billion worth of stuff. I guess.
I am curious about like how much of that is diabetes related.
It is. A lot of it is all these unhealing ulcers and wounds, all diabetic related, mostly diabetic related. But the alternative is amputation. So
I mean, you definitely can go for that.
It's like no one wants that, right? So I mean, it's like I'm not advocating for save the money, don't save the foot. I'm like, if it costs $250,000 to save your legs, I mean, most everybody's going to want that. Medicare doesn't want to see that happen either, so they'll pay the money, right? But a better, more affordable option is definitely ideal, right? So what if there was a material that could heal that ulcer, that non-healing wound up in a fraction of the time? What if they could do it in half the time, right? And it doesn't take 6 or 8 or 10 applications of a very expensive biologic product to make that happen. Right. It would drive the cost of healing that wound down to, a few tens of thousands of dollars over the course of a couple months, and oversight from a wound care doctor. Well, they just lost a tremendous amount of revenue.
They sure did.
Why in the world would he want to promote what I'm doing?
Oh man.
Right? So, and this is what he told me.
Well, of course.
He straight up told me. He said, look, he's like, sorry to interrupt you.
No. I'm interrupting you. This is good.
He said, do you have any mechanism or means for the doctor to make up their losses? And I was like, what are you talking about? He was like, well, I make X amount of dollars, and he's like close, $250,000 on a pretty, I guess, average to average.
How about you can see 20 more patients?
Oh, I know. That's what I'm saying. Like, so he was like, I make all this money. How can you make up for that with your product that can heal this wound up in a fraction of the time or half the time? Let's call it half the time. And
you could set up a wound center and have PAs do the thing, and I don't know. That's such stinking thinking.
Well, I mean, exactly. But I mean, at the same time,
but I totally see the. It's all about incentives, man. Right. And I had this conversation last night about a different subject, but like it's all about incentives, and what if we have poor incentives, we're going to get poor results.
Well, yeah.
For example, what you're talking about with the GMOs, like if the incentive is to have a beautiful piece of fruit, like if that's your incentive, then you're going to do whatever it takes, even if it means hurting your consumer, to do that
because it's going to sell, right? And you can stay.
If your incentive is to bring out the healthiest, best fruit for the consumer, well, you're going to do something different,
right? So you're absolutely right. And we'll go back into the plant thing here in a few minutes. But
yeah.
So I talked to him. He was like, well, he was trying to say his first thought went to how do I keep from losing millions and millions of dollars in my practice by your product healing up wound care patients in a fraction of the time, costing Medicare a fraction of the money. And I'm just like, I kind of laughed and I was like, well, I don't have an answer for you because this whole concept is meant to do exactly what I just described, to heal up a wound in less than half the time, or maybe even just ideally half the time, but with a fraction of the money spent on materials and applications. Because the real expense here is on these amniotic membranes in the wound space right now. And I used to make these in the lab. I mean, this is what my companies did years ago. I had 2 different biotech labs that I've owned and operated, and we made this kind of stuff. But you take this, it's a dehydrated amniotic membrane it's Medicare approved for this. And this is FDA approved for this. This is not experimental anymore. This is an approved product that is used to treat wounds and heal ulcers. And it's expensive because it's a donor-based product. You have to actually collect the amniotic membrane from a willing donor who's just had a baby, and they are going to dispose of all those birth materials, right?
Right.
So there's an approved FDA process for asking a patient, can we have these materials instead of just throwing them in the garbage, right? And the patient saying, sure, you can. I'll sign over a consent. You can have these leftover, placenta material and the membrane. And of course, that patient has to undergo some questionnaires and testing to prove, that they're, healthy enough to do it. But then they donate that, and that can be turned into these. Well, that process is expensive and it takes time. It takes labs and to turn that product. But then at the end of the day, it can actually save someone's foot or save a leg. So I'm like, okay, so that's where it's very, very valuable. It's also very expensive.
Yeah.
And it might take 5 or 6 or 8 or more applications of this very expensive membrane to heal that wound up so you can save that leg, right? So at the end of the day, it's all for good, but it's very expensive. But the structure of scientific revolution's concept is that in order to bring about the next best thing, the people who are in control of the current thing are effectively going to have to grow old and die before the younger generation will accept that they aren't going to make buku millions on wound care. They're going to make average millions on wound care, using this new advanced,
or come up with a different way of doing it. You know?
Exactly. So, and the same thing in university academics is rife with this, if you will. I think that's the right word, rife. Yeah. Okay. Yeah. It's not ripe with this. It's rife with this. But like it's rife with thought leaders who built their career off of a concept and don't want to see it be sidelined by the next up and coming concept that someone they may have even mentored coming along behind them with something better.
Right.
And then so in order for that person to be fully allowed into the system, this guy has to retire out, effectively, quote unquote. They say die. Not all of them have to actually physically die, just have to die out of the control position.
Yeah.
Right. The new person comes in, the concept is accepted, and the new protocols are set in place.
So slow.
The world advances one generation at a time. Right. And in medicine and science, this is exactly how it works.
Now, I'm trying to think of the reasons for that. And I mean, I understand the emotional, the pride, the human reasons for that, but the systematic reasons for that, because you would think some entrepreneurial guy like yourself would just go, okay, well, I'm just going to bypass it, you know?
Well, yeah. I mean, so, okay, in the last episode we recorded, I mentioned that one of my concerns is that whoever I partner with or I sell my company to one day buys it just to shelve it.
Right.
Right. And that happens all the time. And I've actually been warned by multiple investment groups to be aware of that, because one of my contingencies on partnership has been the requirement to move it into market.
Bring it to market, right?
You have to bring it to market.
I remember you saying that. Yeah.
Yeah. So like anyone I do business with, I'm like, okay, so just letting you know that this is a requirement. And basically, if you fail to do this over a certain time period, then your deal is voided.
Yeah.
You know, so like your investment is required to get to most of the young investment, early investment, they want to get it to market. But anybody who comes on later, they might be buying it for ulterior motives, like to add to their value, but not add to their revenue. Meaning they're not going to take it to market and sell it. They just want to keep me from selling it or keep my company from competing with them. But they can actually boost the value of their company by owning it, even if they don't actually sell it.
It's the Google model.
Yeah, exactly. Google buys everything and then just makes them more valuable. Mm-hmm. So but that is definitely possible. So I don't want to branch too far off. I can give you a cool example of a company.
Go ahead. I got some stuff in my head that we
go back to CRISPR. And go back to
go back to apples,
fruit, to apples and fruit, which anyways. So.
This is why, by the way, this is what I love about long form podcasts. We can do this.
This is fun, yeah. So there's a company I've known for years. They are probably the largest regenerative medicine group. I'd say one of the largest in the world. They operate here in the U.S. They built their house on PRP, which is like 2 decades ago. It was just coming into market. Mm-hmm. Take someone's blood, spin it down, spin out the platelets.
Yeah.
Right. Then you can inject that back into anywhere you want in a concentrated form.
Yeah.
Right. So super awesome treatment. Really is. Revolutionized a lot. Then introduced into the entire world of birth tissue biologics, which are where you take that same donated material I talked about earlier, and you can take that, you can take that material, that amniotic membrane or the cord tissue or a placenta, that's just leftover, discarded. It has nothing to do with unethical interactions with a mother and child. It's all just what's left over.
Right.
It's like, millions of babies are born every single day and they toss all that material.
Yeah.
Right. It's just all garbage, like all the leftovers. If you are willing and able to process them the right way in a lab, you can make them clean and make them usable in the regenerative medicine space. So that's what my companies did. And so anyways, we made these products. There are some definitive advantages over not having to do a blood draw and collect the PRP out of a blood spin down and all the work that goes into it. you could just make a over-the-shelf product that you can inject. And in some cases, the growth factors and elements of this birth tissue injection product might even be better in certain cases. Not all cases, but the company that I'm talking about, they built their whole network of doctors. Their whole platform is based off of PRP, and they did all their research on PRP. So they go and they take that, and here's where they win. They win because they have all this data showing that their PRP works so well.
Right.
Right. No one else has put in the effort to collect all the data on all the other stuff. So when they go and talk to some insurance company or someone and say, are you willing to cover this treatment? We can show you, here's our mountain of data we've collected over the last 20 years showing our outdated PRP treatment from 20 years ago is the best thing that you can do right now.
Right.
Right. Even though there might be other things that are absolutely better now, but they don't have the data to support it because no one's put in the effort and time to do it. But you've got all this data.
And institutions like insurance companies are always going to be more conservative about that sort of thing.
Absolutely.
Where a person would be like, I might try,
So, okay. So it's so funny. I mean, like that's the whole regenerative medicine space for probably about 10 years. It was kind of, we call it the Wild West of medicine because we were making birth tissue products. There's tons of companies I was one of the first companies in the market back then. There's maybe like 2 other large companies at the time. We came into the market competing with them. And then probably within 3 or 4 years after we opened our doors, I saw like a dozen new names and brands coming to market. Tons of people reaching out to me to help them start a company. I had probably a half dozen different companies reaching out to me to help them build a lab to make stuff. And I had one company wouldn't leave me alone, and they were just annoying. And eventually they did some stuff inappropriately and got in trouble. I was kind of like, haha,
right.
Glad I stayed away from you guys. But so that being said, though, that market was kind of open, and doctors could see what we were doing. Patients were willing to get the treatments, even though none of it was FDA approved. Yeah. Right. But insurance is very conservative. If you're going to get it reimbursed, insurance now has liability for allowing it in their system and then paying for a treatment. So I actually met with the medical, who's the chief medical officer. It was the chief operating officer for Optum Healthcare, and I think it was the chief medical officer for United Healthcare. Okay. Met with them years ago in a 2 different 1-hour conversations on trying to get a pure amniotic fluid. So amniotic fluid is one of the options. You have all the actual physical tissues, and you have the actual fluid. Mm-hmm. And that fluid is wonderfully perfect for regenerative medicine. I used to call it nature's ideal regenerative medicine. Really? Yeah. Because it is it is what children are developed in. Yeah. Right? It has the perfect ratio and concoction of growth factors, everything else, safe, right? Right. Babies drink amniotic fluid continuously. I used to joke because so I'll go back to the scientific revolution's doctors in a second here, but I met with them and they loved it because we could produce it at a price that was even cheaper, and we can make it available for even cheaper than what they were being pitched for PRP, which required work and a blood draw and all this stuff. Mm-hmm. We could produce this product for them, and we could actually make it standardized so that it had roughly the same composition for all the batches. They loved it, except for that it wasn't FDA approved. And they were like, oh man, we would totally do that. This is so great. It would save us all this money on all these other things and surgeries. Steroid injections are notoriously over the last few years, they've been proving more and more destructive than we ever thought. Oh, wow. People are getting steroid injections in their back and epidurals and all this other stuff. And all the data is coming out now that these steroids are deteriorating the nerves, making it worse, and then triggering a faster path to surgical interventions. Wow. Right. Knee joints and osteoarthritis, people getting routine steroid injections in their knees. And that's the only thing they're being offered in all these offices. Right. PRP is a better option. And so one thing I do like about this one company that I mentioned earlier is that they are offering, they have the data and they can prove that it works. Right. There might be something better, but they're not interested in that. They're interested in this. Right. And they have actually proven it. And now everyone is moving forward. That's how it's a 20-year delay. And that's how long it took and they're still not, by the way, they're still not FDA, they're still not Medicare approved.
Wow.
The
Which is a whole other problem.
Right. The processes are FDA approved, if you will, like the materials and processes and mechanisms for doing it, but the treatment itself is not necessarily FDA approved for what they're doing with it in all cases.
Right.
And then Medicare still does not reimburse for it. So there is some reimbursement available for select conditions, right? But now this company is going to all the private insurers and negotiating specific deals with them for the treatment, which is great. It needs to happen. The more of that they get, the better. Well, I was talking to the CEO. I've known him for years. I'm like, so why don't you guys acknowledge or integrate some of these more advanced up and coming therapies that have amazing data? I've got research articles I can show you where patients are regrowing cartilage in their joints, regenerating nerve tissues, and all.
Really, that's insane.
Oh, it's amazing. Yeah, it's amazing. Well, his whole thing was, but we basically, he's like, we built our house on PRP. If we even acknowledge that the other stuff is better, we immediately transition ourselves out of the market because everyone will look to this other company who holds the authority on that subject as the company. And now they will be second fiddle to the next best thing that's coming along, and they'll start to slowly lose their value in the market. All that work that they did will now be, so what do they, so they position themselves as an innovator in the field, but what are they innovating? Better ways to process PRP.
Yeah.
That's all they do.
Yeah.
Right. All they do is work on better ways to make PRP, and they just came out with a new, better device and they're calling, we were innovating regenerative medicine. And I'm all like, well, not really. I mean, you're contributing to the body of knowledge, which is great. You're probably innovating some methods and ways of the equipment to be used, but you're not creating anything new. And by the way, tons of people do this outside of your company. So you don't really own the market, but you are one of the leaders, and you very well could accept something else.
Well, and this is, I think, a problem that a lot of companies have, is that they forget what business they're actually in. They think they're in the PRP business, or they think they're in the the loan business, or pick your favorite thing, and when that's not the case, they're in the helping people get healthy business. They're in the helping people become financially free business, and when you forget your business and you can get locked into those things, if you open your mind to saying, hey, I'm in the health business, I see this other, and this is just me thinking, spitting off my I know nothing, right? But if somebody has enough foresight to see this stuff coming, there is nothing wrong with going, okay, we are going to incorporate this, and now we are the leaders because we've already incorporated this in to our business model. So, to me, obviously it takes a profit almost. It takes some real insight to pick out those businesses. I mean, it does. This is
invest
legit.
In that business. Yeah, absolutely.
Right.
Yeah.
But it does. It does keep you from the inevitable failure that will happen, because maybe it's not your generation, and that's fine. Like if you just want to make your money and go away, that's fine. But if you want to maintain like the business model that you really want to be in, you have to look ahead.
So I mean, I could probably think of a half dozen pretty significant names that aren't around anymore for the same reasons. Yeah. Right. Blockbuster.
Right. Right.
Kmart. Mm-hmm. Radio Shack. Who else? I
mean, Circuit City.
That's Circuit City. Yeah, the big, huge.
Love Circuit City.
Yeah, the red box square that plugs
Virgin
down.
Records. I think there might be one of those left.
Yeah,
Tower Records.
Yeah, there's so many companies that did not. I mean, the innovation came out. What if you're up and coming and you went to them, right?
Right.
Most of these big companies had been pitched the thing. What is it? It's not Polaroid. Is it Polaroid?
Oh, Kodak.
Kodak. Yeah.
Kodak. Yeah, for sure. Yeah.
Most of these companies have been pitched the next thing, but they built their house on this thing.
Right.
Right. And so they want to suppress this thing. And it's the worst thing in the world. And there's another book called The Innovator's Dilemma, and it talks about this specific concept, about a company or a person in general, a concept that is put on a pedestal, and it's the thing that you worship. For your thought concept is on that, and you suppress everything else, even if what you are being presented to will surpass it. You should adopt the new thing.
Absolutely.
But you don't. So what you do is you give them fuel to go out and do it on, and they'll do it without you. And all of a sudden you have Netflix and Blockbuster gets nothing because they did not accept it, right? Everyone can see it now, but at the time, Blockbuster thinks they're in charge, right? So
IBM and Microsoft. I mean, there's a million examples just like that.
Going. So if you think you're in charge and on top of the world, then why do you need to listen to the up and coming person who you could literally just sweep them out of your building,
right?
You know, and then you don't have to think about them anymore, and you still are in charge for today.
Yeah.
And then whatever it is that they have that's better will eventually get to market without you.
Right.
Right. So this one doctor I'm talking to who's like, "Oh, how are you gonna make it up to me and all my
Exactly,
millions?"
yeah.
And I'm all like, "Well, here's what I'll do. I won't make it up to you. What I'll do is I will bring it to market anyway, and then you will be told exactly what to do with it by Medicare."
Right.
You know, Medicare and Blue Cross and United will send you a letter saying you will use it this way.
Yep.
Right. You will not be allowed to use 10 applications of this other expensive product until after this one has failed. Right. And that's what they do.
And instead of being on the forefront and being a market, first to market kind of person,
he could be promoting it.
Yeah. Now you're going to be,
So he could be a voice that became famous for it. Now he'll just be another one of the bricks on the wall that are being told what to do because he did not innovate it. So like, and that's the medical case. And every doctor hates that concept of they can't practice medicine because the way they want because insurance tells them how. I get it. Everyone knows it. It's a huge ship. Can't turn it very easily. It takes a lot of work. But that's the world I've been playing in for years. But that's what happens. I mean, so innovator's dilemma, all that stuff, going back, scientific revolutions, going backwards here.
Well, yeah,
CRISPR,
I mean, CRISPR,
apples.
well, I think like we're talking about like where the new innovations in science and in health, in in longevity, I think from the very beginning, we were talking about like how things have changed so quickly and so fast, and what are some of the things that are that you see happening that maybe are to market or close to being put to market?
Yeah. Okay. So one thing that you can do right now, I'll say can do right now in the market is have your own stem cells harvested.
Okay.
And then you can have them cultured and expanded, so you can grow them out. You pay a lab to do it, and then you can have them stored indefinitely in a bank, in a cryobank.
Okay.
Or a lab, and then you can actually have those cells whenever you want them the rest of your life, and you can do that all you want.
Okay, so I want to slow down on that just a little bit because I know that stem cells are valuable. I know that people who have leukemia, they'll get stem cell donations and things like that. But from a just like a typical, like, why would somebody want to do that? What are the applications to having stem cells in a bank?
So currently in the U.S. market, you can't really get stem cells very easily, right? That whole thing I told you about with birth tissue donations, the FDA has cracked down on that a lot.
Oh, really? So that's really hard now.
Very hard to get any over-the-counter injectable product that a doctor is actually willing to use right on you because they know it's in the radar of the FDA. You're selling. FDA came out a couple of years ago and said everything made from birth tissues that's an injectable is a biologic drug and it's going to require drug trial to be able to use it in the market. And since they made that announcement, every company that made those kind of products is out under the microscope.
So it's not because it's inherently dangerous or they've had some studies come out that say, this could harm somebody. It's more because they want another bureaucratic way to
the FDA
control it.
It's like any other governmental organization. The more control they have, the more powerful they are.
Yeah.
The more value, the more appearance of value and appearance of essentialness they have. I'm not insulting them in any way. That's just any organization.
I will. It's okay. You don't need to.
You can do it. I can't do it. The FDA is amazing. No, I'm just joking. No. No, they are very, very good at keeping a lot of bad actors out of the market. That I agree with. Rapidly accepting good things into the market is not their forte, right? Theirs is based off of a negative reinforcement, model where, We'll make you prove everything and then only let a few things through.
There has to be a better way for that.
Well,
I don't know what it is,
but you would think, and I've looked into this as well. I mean, because everybody first, like I'm saying something right now that I'm about to backtrack on a little bit, not because I'm afraid of the FDA, but because of the reality of the situation is that you really can't know what is going to turn out to be good or bad until after extensive studies.
Yeah.
And if you are going to be the one who signs the paper for that, who's the one who's going to take the liability when someone starts getting hurt?
That's the incentive, right?
That's the incentive is where you've heard the phrase CYA.
Yeah.
You know, it's like everyone in the process wants to cover their ass, right?
Yep.
If you're going to be the one who's signing the document, right, you better know what the data says, because
which is why you want a 10-year study.
Right. So I don't blame them for wanting to do it this way. I get it. The FDA is though very I say open to people trying to get things into the market. They want people to do it. They provide avenues for assistance and help to get in the market. It's possible to get things through. Some scenarios it's very easy to get things into the system. Some things it's just not. And so the birth tissue stuff, a lot of bad actors. I'll be the first one to say a bunch of bad actors in the field on all sides. As soon as people realized there was money in this, you attracted everybody, right? So I used to get asked this question all the time. Why is it so expensive? I'm like, well, because the doctors doing the injection can charge that much. Well, why is the product so expensive? Because the company's making it can charge that much. When we made it, I'll just grant everyone some really sickening insight to the money structure here, right? My very first lab, we could make a vial of injectable. Back then, everybody called everything stem cells, but it wasn't. It was a amniotic membrane morcellized tissue injection. So basically, we took tissue and we biodissolved it into an injectable form.
Okay.
Right. So the cells are still mostly viable, but it was not pure stem cells.
Right.
You can't isolate those in that model. That part is illegal to do in the U.S. But we made this injection and sold it to doctors, and they gave it to patients for pain, joints, things like that. Worked amazingly well, right? We could make that 2 cc vial of product for like $50.
Okay.
$55.
Yeah.
Right. Was our actual cost of goods to make it. Now that's not all of our company's costs included in, like our salaries and whatever.
Right, but that's your products, the bottling.
Yeah, it's like that. Yeah, if you were to factor in with some modest sales volume, factor in all of our expenses, you're making like $150 for a vial, right? It's how much it would cost to keep us at where we were. We sold that for like $1,200.
Yeah.
Yeah. So like 1,000. We started. It used to be 2,000 when we first got in the market. It was $2,000 for that vial that we sold. Then we dropped it down to $1,500, then to $1,200, and then with more competition, we dropped it down to $1,000 for that 2 cc vial. And then doctors would turn around and they would offer that vial, 2 cc vial, as a knee injection for $5,000. So you have a $5,000 knee injection that costs $50 to make.
Yeah.
Right. And the doctor took them less than 5 minutes.
And
to
by the
inject
way,
it,
and I think like people may look at those numbers and be like aghast at it, but no, that there's a lot of factors. There's first to market factors there. There are the fact that there's not alternatives. I mean, that is the alternative.
Yeah.
I mean, so and you want that, and I got to emphasize that. That is not a bad thing. That is a good thing, because what that does is that brings other people to the market and allows for more competition to happen.
There's viability in this market, and everybody sees it. So you have 100 companies jumping in and innovating. You're absolutely right.
Yeah.
But then the FDA has to say, well, there's all these characters in the market now.
Right.
Some of them are making stuff that we don't know what it is. Right.
Which is bad.
What is this stuff? Right.
You put honey in this vial? Come on.
Yeah, seriously. It's like there's all sorts. But these companies know the risks of if they make something that's going to harm a patient. So at the very least, they're trying to make them sterile and clean.
Right.
But unfortunately, a company back in 2018, trying to rapidly sell product in the market, they let a bad batch through. Had I think maybe a dozen patients out of a batch of several hundred units that went out. They had about a dozen patients in it. Hospitalized with infections. Wasn't my company. It was one of the companies that tried to hire me though. 2 or 3 times they reached out to me at conferences all the time, send a rep over to me to see if I was willing to leave. And it was pretty funny. Anyways, they're not in business anymore in the US. They are internationally, where the media doesn't really have as much pull
Right,
in the country
right.
to promote how bad that they were here in the U.S. But that being said, there's reasons why you want some oversight. So all those birth tissue products, things like that, all that stuff, it'll be back in the market. There's companies bringing it back to market in the official capacity. They'll go through the drug trials. They'll get it approved for use and what it does. It'll be back soon.
And my guess is like anything else, like once people have, blazed the trail, it gets easier for number 2, number 3 to get through to that
So it
stuff.
actually officially does. And this is why no one bothered to do a drug trial on these products before, because first you didn't have to.
Okay.
Right. You could go into the market as was called a 361 biologic, which was just a true biologic product, which you're claiming. And then back then it was what you were claiming, right? Are you
right.
claiming that you're a genuine biologic? Or are you claiming you're a drug? Well, we're not a drug,
Right.
And the FDA is like, okay, well, that's what you wrote down on your paper. We'll accept that. And then we'll investigate later and we'll figure it out. So companies were operating for years under the premise that they were a genuine biologic and not a drug. And then they just kept selling in the market. So if they did do a drug trial, they would have spent millions of dollars in years to prove something that they effectively believe they already have, a treatment that works, and they don't have to do that to get it in the market. They can sell it right now. Why would you bother doing a trial? Doctors are buying it. Patients are buying it. The FDA is not stopping you. No one's getting harmed. Most people are having amazing outcomes. Why would you jump through the hoops of a trial if you didn't have to?
Right.
And so that's why the FDA had to come out and say, no, everything has to go through a trial now, right? That's why they had to do it. But let's just say you did go through a trial, right? All I have to do, it's a biologic product. It's not an invented pharmaceutical.
Yeah.
It is a biologic product. I can make an identical product to yours. And if you alter yours, then you have now created a new drug. Right. So you can't change it. Okay. And it is a biologic product, and I can make an identical version of it. And there's a thing called a bioequivalency application. So all I have to do is prove that mine is bioequivalent to yours. And that application, if I remember correctly, that's like $100,000.
Wow.
$100,000 and maybe like a couple of months worth of testing for sterility to prove that it's not going to hurt someone.
Yeah.
And then I'm in the market.
Wow.
So $100,000 in a couple of months, and I'm in the market competing with brand A, right? Who spent $10 million in 5 years getting it to market. So that's the pioneer with the arrows in the back.
Yeah.
You heard that phrase. So whoever spent the money basically paved the path for everyone else to come in behind them on a product that can be replicated.
Yeah.
It just isn't worth it unless you can control the market. So all these companies were trying to create new versions of products, something that they could patent.
Right. Something that's patentable, something that they can control. Yeah.
Oh, we make it this way. It's patented. No one else can make it that way. I'm like, yeah, but ultimately all I got to do is prove that ours is the same stuff.
Right.
Right. Same levels of stuff.
If I can make it in a different way and have it come out the same,
then I can prove bioequivalency and I'm still in the market. So no one wanted to jump through the hoops. I know of one company right now who's actively engaged in exosomes.
Okay.
So that's for all the listeners. Apologize for the billions of topics that I roll through here in my time. Exosomes are the little growth factor signals that are released when a stem cell is grown and replicated in a dish.
Okay.
So if I take stem cells and I implant them onto a growth dish and I put in some growth medium, which is just a bunch of nutrients, almost like chicken soup, kind of thing. The cells will, it's actually more like a blood-based kind of serum. So anyways, no one cares. Chicken soup is what you use for E. coli. Anyways, and it smells like it too. It's almost like you technically could drink it. It's sterile. It's sterile, but it does smell like chicken broth. It's chicken broth.
Okay.
For E. coli. Oh my gosh. Sorry, sidestep.
That's all right.
I'm going to go right back to the growing stem cells and exosomes. But some of my most memorable smells in the lab are the distinct smell of E. coli growing in chicken broth.
That's wild.
And also, when you kill everything with Clorox, the distinct smell of Clorox and bleach interacting with a
chicken broth
with a chicken broth E. coli solution. That's like I never forget the smell. It's like I think about it. I'm like, oh my gosh. And people used to laugh. Like,
I can see your nose.
Yeah. Some people, it doesn't bother some people. And I'm like, that is a concoction. I can't get it out of my olfactories.
It's amazing how like memory is triggered that way. You know,
I have another scent from cadavers and when I was a advanced anatomy TA, I used to actually oversee the dissection of humans, and that there's certain smells involved in that I never forget. And there's certain foods I can't really eat without vividly remembering.
I can imagine
cadavers. It's interesting. So, anyways, I'll talk about that in a minute. But okay, so going back to growing stem cells, I grow stem cells in a dish.
Yeah,
they'll culture and expand, and they will put off these little growth signals. That's what they do. That's their job. And they put them off in the form of a little lipid vacuole. It's like a little mini cell. It's super, super tiny. And inside of it are all these little peptides. You've heard of peptides, right?
Yeah.
Everybody's growing peptides. Well, how do you think they grow peptides? AKA, I already told you.
Sounds like,
AKA insulin is a peptide. So how do you grow peptides?
Okay.
In E. coli.
In E. coli.
Yeah, in
of
bacteria.
Course.
You just grow them in bacteria. All you need to do is insert the right gene.
Okay, so hold on. And I'm sorry, I'm dumb. What's a peptide?
Okay, so yes, a peptide is a small chain of proteins.
Okay.
Right? And proteins are configured in a certain pattern, certain shape, and they will create an effect on the right receptors.
Okay.
So if you have a cell and the cell is hanging out over here, and then you just throw up a bunch of peptides into the wind, right, and they land all over the cell, then certain peptides are going to land on one of the cell surface markers.
Which is going to tell the cell to do a certain thing.
And it will configure it and open it up, and it'll let in something, or it'll change something, or it'll spit out something. It'll tell it what to do. It might even trigger it to replicate.
Okay.
Right? So peptides are signalers. So I like this. Going back to apples. Boom, back to apples. Here we go. High five on the apples. Woo. I use this in my books when I explain this. Stem cells are an apple orchard.
Okay.
Right? They're growing.
Yeah.
And they're producing something. Exosomes are the apples.
Okay.
That they produce.
I like this.
That's how it looks. You know, they produce them over and over and over. You harvest them, and you got apples, and you squeeze those apples out, and you got peptides.
And that's the juice.
That's the juice.
Oh, that's brilliant. Okay, I understand that.
Orchards, apples, juice.
Gotcha.
Right? Stem cells, exosomes, peptides.
Okay.
Right?
Very cool.
That's how you do it. So you could go straight to making juice, right? You could just take a piece of DNA, throw it right into a bacteria, and its engine will turn on and replicate and replicate and replicate. It'll make that same little piece of protein over and over and over.
I gotta say, that's gotta be exciting. Like,
it's fun.
Like all of a sudden, like you know, you're just like, you know, I mean, this is kind of morbid, but it's kind of like sticking electricity on like a dead chicken or something. Like to see it go woo woo. But like to see like something that you made.
We did that with frog legs, right?
Okay, right.
In biology, you can a dead frog leg, you can watch it jerk. Yep. Yeah.
But if you take, but to see these peptides interact, you know, with these molecules in these stem cells and do something, it's got to be pretty cool.
It is very, very cool. So the world of peptides. So I remember from one of the first companies in Southern California that was making peptides maybe like 10, 12 years ago and trying to come to market with it. And one of my partners at the time, super brilliant guy, he said it takes a prophet sometimes to see things ahead of time. This guy is like that. He sees stuff, but nobody goes along with him. And he's from Texas, and he's got this draw, and I love him to death. He's one of my best friends. And I'm all like, well, Mike, you see what's going on here. I hope he listens to this one day. His name is Jeff. I was like, you see what's going on here, and you explain it to people, and they stare at you like a deer in the headlights. And then they move on with whatever else they were doing. Meanwhile, this entire billion-dollar industry pops up right on the other end, and you didn't have support from your team to get in on it.
Right.
He's been like that for years. He sees what's about to come around the corner.
Yeah.
No one pays attention to it, and I think it's because he's so calm and casual and has got that drawl. He's like, "Bye, y'all. I think we should go after this peptide market. Looks like the peptide market might be the next big thing." Right. I've been researching in, and so with his Texas accent, he's throwing out scientific terms.
I've been fixing to learn something about this.
I'm fixing to learn you about some peptides, and he's not really that bad. I mean,
no, I know, but I love it. I love everything about
Alabama.
that.
I should have a worse draw, but his is definitely Texas. Is not Alabama.
Yeah.
You know? It's like I can nail some.
Can you?
Some
Some of those southern.
Some of those accents. Man, I was on the phone with someone as a doctor just a couple weeks ago.
You just slipped.
Yeah, I did. I was on the phone with someone. I was on the phone with a doctor a couple weeks ago, and I was like, "You're from North Carolina." He was like, "How did you know?" And I was like, "You sound like you're from North Carolina." And he was like, "No way." And he told me he was in Colorado now. And I was like, "But you're not from Colorado, huh?" He's like, "No." I was like, "North Carolina." He's like, "What?" And I was all like, "Oh, I can tell you there's one or two words that are just spot on North Carolina." Anyways, but that being said, Jeff will tell people what should be done and how to do it, and they won't do it, and then they'll miss the boat. Poor guy's had a hard time getting people to just, do what he thinks is the right thing to do on this business venture, and then have his partners go along with it. If he had $10 million, the guy would probably change the world, right? I've had that said about me as well. If I just had $10 million to work with, I could change the world. Jeff's the same way. $10 million, and he could have some amazing.
What did they say? A prophet is never, resounded in his hometown or something.
Yeah, exactly. Yeah. So I mean, we could have been in the peptide market 10 years ago. Peptide market has come into the medical field lately. Tons and tons of functional med doctors, wellness centers, naturopathic offices, all using peptides, prescribing them to people for injections.
Yeah.
Right. For different purposes. And some peptides are really good at doing this thing, that thing. Semaglutide, Ozempic, all a peptide. And how do they grow that?
Wait. Let me guess. E. coli.
E. coli. Likely. I can double check on that. I want to speak out and somebody hearing this and be like, no, they don't. They use this other bacteria that's from something better.
Does it glow?
No, they probably don't put glow on. They don't waste their time.
They know how to do it.
They know how to do it. Yeah, that's for idiots like me who needs to. Did it take it? Did it uptake it? I can't see. Turn off the light. It's got to glow. I can't see if it actually worked. Yeah, nobody's doing that in these events. Actually, I take it back. Some of these advanced labs are using glow genes to identify, but they don't do it for their routine productions. I don't think.
Right.
But
I'm sure once they have their process down,
you should see these. Some of these like cool bins full of these super cool flasks. These these Meyer flasks, the ones with the cool big bottom on it.
Yeah.
And it's this big machine. It just rocks and circulates them in a little circle pattern.
That's cool.
And then it just smells like the whole lab smells like E. coli. Yeah. It doesn't stink like you think. All the other bacteria make, things like that stink, but E. coli just has a weird smell to it, and then they just grow it. And you look at this little dish of chicken broth, and you're like, this
is a weird question, I know, but like if you've got a flask of E. coli,
mm-hmm.
like what's the saturation level of what?
So this is how they do it. Yeah, there's a point where
when do you know you're done?
The nutrients are used up and the waste products are overpowering.
Yeah.
You could probably make some continuous cycle systems for this, but it's not worth it because they don't need to. They'll just cook it and kill it and get it all out.
Well, yeah, you can I'm sure it's pretty abundant to find.
Yeah, I mean, yeah, exactly. Yeah. And they grow them. So there's actually I was actually pitched this by one of my biotech professors. An easy company to start is a company that makes what's called competent and ultra competent E. coli cells.
Okay.
All we would do is culture and grow E. coli cell stock so that you can take a little vial and inject some E. coli into your system and then grow a gigantic amount of E. coli. To have them, an ultra competent E. coli is one whose cell wall is slightly adjusted enough to allow in some DNA.
Okay.
So that it can replicate.
Okay.
And so you have to, you can make it competent and ultra competent. It means it's readily able to accept a DNA it's called a plasmid.
Yeah. It's
a little section of DNA. And we grow those using PCR. So we'll actually grow the gene that we want over and over and over in PCR, which is just a little it's a little slurry of ATGC.
Yeah.
It's the Jurassic Park slurry.
Okay, right.
and you throw in a gene, and then you just simply go through this rapid heat and cool cycle over and over and over and over. Every time it cools down, that little piece of DNA is matching up with every molecule identically, every molecule that it needs to replicate itself. Heat it up and it splits apart, and you've got two copies of the same DNA.
Cool it down.
Cool it back down, and both of those will pull in all the ATGC to match it on the other side, form another whole copy of DNA, heat it up, break apart all four of those.
Oh, that's so cool.
Right? Now you cool it back down, you got 8 copies now,
right,
over and over. So you cycle that PCR, and you can make 1 billion copies of the same piece of DNA. Well, now you take that, and you can insert those copies of DNA into your solution with your E. coli, and they are uptaking these little fragments of DNA and they're putting it right into their little gene center where they just replicate it like an engine.
Oh, that's cool.
We do the same thing, by the way. We could just accept DNA from the environment, but we don't. We have all these protections in place. We have skin and everything else, and cell walls and everything. But if we just came across a plasmid on the ground and we stepped on it, we could technically just absorb it and start replicating whatever it is. Right? I mean, like, so we just don't do it.
Right.
But cells do it. I mean, the cell's just walking along by itself, and it's got some,
especially if it's ultra
competent. It's got some competency issues. Right?
It's learned well.
It's learned well. Yes, it's very competent, and it just comes across and smacks into a little plasmid, and it'll just take it right up and make whatever that is.
That's cool.
So you could teach it to make anything you want, and then of course you have to kill it. Unfortunately, it's just
Yeah.
But then that's how they do it. So you could make a protein. You could make a peptide, and you can make that into a treatment for a patient.
And you're saying what these things kind of do and what they...
Right. So they can do all sorts of stuff. You can make different peptides by just isolating whichever gene you want to make it, have it made and reproduced in the lab, and then you can refine it, turn it into an injection in a fluid in a pharmacy, Here's what's cool about stem cells and exosomes, going back to that. So remember, the peptides are the juice. Let's go to the apples, right? The exosomes are a little lipid vacuole. Do you remember in the cell, do you remember the Golgi complex?
No.
The endoplasmic reticulum.
Yes.
Endoplasmic reticulum.
Okay,
Yes.
I remember that.
Okay, yeah. So if you're looking at a cell nucleus, all around the nucleus you got this endoplasmic reticulum.
Yeah.
The DNA in the cell is replicating. The DNA is its entire purpose is to make a protein. Right. It's got a sequence that is designed to make a protein. We're actually made of protein, right? All sorts of proteins. That's what our hair, skin, eyes, eye color, heart, everything else is all made of proteins, right? So it's going to make this protein, and it's going to cycle it through what's called a ribosome. Remember that thing? Cycles it through that. Well, what's it do with all the stuff it's making? It's making it's got a cycling the DNA through a ribosome, and it's just spitting out all these proteins. Well, all those proteins are going to go over here to the edge of this lipid endoplasmic reticulum. It's all right there, and it's going to just pop off.
Right.
I made that sound so everyone can imagine it. Just like, do you remember that the lipids are attracted to each other?
Yes.
So that's what they do. They'll make a little lipid vacuole. It's empty on the inside, and that's what a cell is. Remember, the cell wall is made of lipids.
Yeah, that's right.
And so this little endoplasmic reticulum is a whole bunch of lipids, and it just pushes this little bubble of fluid full of peptides through the lipid, and then it pushes out the other side and closes up. Now you've got this little mini cell, little vacuole. Yeah. That's a lipid vacuole filled with peptides. And then it goes to the edge of your cell, the actual cell wall, right? Yeah. And because it's made of lipids, it's allowed through, because the cell wall lipids will recognize and absorb it through, and it pushes right through the cell wall. Right. So
it's got the right key combination.
Yeah. So that little exosome pops right through, exits the cell, and it can go, and guess what? Because it's made of lipids, when it encounters another cell, guess what the cell's going to do? Loop. It's going to let it right in. Right. It's going to sit on top of that cell, recognize the lipid nature of the surface, and it's going to just absorb it right in. And once it does, it releases all those peptides into that cell. Wow. So that's what stem cells are doing. They are producing all of these growth signals. Yeah. And they're sending out all these stimulatory growth factors and stimulatory growth signals to all the cells around them using those exosomes. Right? That's how they send their signals. The paracrine action. They send it right around the region. Okay. Right? And so all the cells and stuff around it start picking up activity and start growing and regenerating and healing. They're being stimulated by the stem cells, right? So we, as a world of scientific people, decided that we could just use those exosomes instead of the stem cells. just inject those right into where we want them, and they will stimulate all the cells to do what we're asking them to.
And they're kind of like I mean, if I'm hearing you right, they're kind of like the skeleton key from a standpoint of like, whatever you need them to do, they'll do. Like, for example, like, you know, if you need them to, you know, regenerate cells for, you know, for cartilage or skin or whatever, like it'll recognize the need and it'll do the thing.
Right. So, you know, so depending on what kind of cell.
That was about the worst
Well,
explanation. It'll notice and do
the thing it's supposed to do. No. You're exactly right. Stimulation of cell replication is fairly ubiquitous for all the cells. It's probably like, you know, the same exosome is going to stimulate every different type of cell to do its reparatory work.
Yeah.
Right. So it's not going to take a specialized for every single one of them. It could be some changes. I'm speaking off the cuff here.
Sure.
You know, I'm not an expert in knowing exactly what peptides are being produced in each cell, but in general, the idea is that if you can grow the stem cells in a dish, just like you would anything else, it's producing all these exosomes.
Yeah.
Full of peptides. Let's take it. Let's suck it all out. And let's inject it where we want it.
Right.
So the exosome market picked up right after the stem cell market did 10 years ago. I know the guy, I think it's the first guy who actually sold an exosome product in the market. He actually made it in his lab in Florida. At the time, he and I were chatting on the phone once. It's maybe like 10 years ago. At the time, he was asking my opinion on if I thought that was even an ethical thing to do. He was like, do you think people would actually buy it? And I was like, I don't know, man. Like I said, my question
Well, it's still out there.
Oh, I know. I was like, it's like, first off, we know we can't grow and replicate donor cells
Right.
and sell those in the US. That was
Right.
off limits, and it still is. So that birth tissue we're talking about, we can't grow those stem cells and then use that in the US unless you're like in some sort of special trial or something with the university or whatever. You can overseas, though. You can go overseas and get those kind of treatments all day. But in the U.S., you can't get those.
Every professional athlete who gets
no,
injured.
Hey, professional athletes, listen to this. It's probably millions, right? I have better options for you in the U.S. You don't have to go overseas.
Okay, see?
So I question it the more I dig into these international centers. I used to be a big proponent of going international and getting these expanded birth cells. The more I've dug into it, the more I question it, because some of these centers I have seen that I know are fairly shady.
Yeah.
One of them, I was trying to help one group open a center, and we couldn't get approval unless we allowed one of the family members, one of the local health officials, to be a part owner in the company.
Yeah. Yep.
And pay a special fee. And then we could get approval.
Those were air quotes, special fee.
Yeah, exactly. Yep. And I was like, well, this is too shady for me, guys. And they're like, yeah, well, you're going to have to run. Oh, and by the way, that country allows direct U.S. transactions. But for us to get approval from the health minister and his now family member in the company, we had to run all the transactions through his company.
Yeah. Yeah.
Right. I was like, but that was what was going to get us approval.
Right.
And then the next question was, how are we going to source all the cells? And their first question is, we got that covered. Don't worry.
Oh, I'm sure they do.
I'm all like, no, you don't have that covered. I'm all like, I'm going to document exactly where these come from, and we're going to make that very public. No, you can't. And I'm all like, because we keep that information.
That's proprietary, as they say.
Proprietary is strictly confidential. I'm like, okay, I'm no longer involved in this company.
Yeah.
Right. Because you are unwilling to provide real documentation about where the cells are coming from. Right.
Right.
What level of expansion they are in. Right. So that matters. Are they on generation number 5 or 6 in your growth cycle, or are they on generation 10 or 15? Right. Their ability to perform benefit in the body depends on how many cycles in they are.
Interesting.
So you don't want a cycle that's 20 in, but you can make millions of doses of cells at the 20th expansion level. Right. And there's where your margin is.
Yeah.
Right. I can make 1 million vials off of a single piece of,
right.
tissue.
And if I don't have to replace the...
Right. I don't have to get new and better cells to do it. I can make 1 million vials and sell those. I can lower the price and I can outsell everyone, but my cells are practically worthless.
Right.
Right. And so I'm like, okay, so I've had people go into some
Which,
of these,
by the way, is a lot of medical stuff I worry about, like that kind of thing where it's Sure, I'm sure there's scientific data that backs this stuff up, and I'm sure it's helpful to the body. But how do you know that you're getting an effective dose, or that the dose itself is at all working?
If it's international, you just don't.
Yeah.
You just don't. I mean, straight up, you could buy your way into activity there. And then there's these other companies that are funneling people internationally who are looking for treatment to different places, and you can buy that too.
Yeah.
Like there's these, there's 100,000 stem cell centers in Mexico, all of them offering what you're getting in Panama and Costa Rica for $20,000 or $25,000, offering in Mexico for $5,000, right?
Yeah.
And I'm all like, and then of course you can simply buy the traffic that's coming in on these different, international concierge medical platforms, and they're quote unquote, in my air quotes again, vetting everyone.
Right.
Like major BS. You can absolutely just buy the traffic and then have you be the top pick, right? And then your $5,000 treatment is the preferred one, magically,
right?
Because you bought it.
Yeah.
And you have no idea. So I just don't trust any of it anymore. I've seen tons of doctors in the U.S. turn toward these international centers so they can, all because they want to be able to grow allogeneic is donor cells, right? They want to be able to grow a birth tissue stem cell out, make hundreds of vials with it, and then do injections and IVs with it. And it could probably still work. I've seen lots of great treatments happen from that, but now there's only a couple of centers I would actually trust anymore for that, because so many people got into it because the market's big. It's just like here in the U.S. when the birth tissues were all the rage and everybody got into it. And then they, all of a sudden you got shady characters in it. Well, same thing here. All the money is flowing into international treatments and all these shady characters getting involved,
Right.
So luckily here in the U.S., there was a ruling that happened about a year and a half ago. Most people still don't even know it exists, but it happened, and it's changed a lot in what we can do. And this is what I promote now actively. But a federal judge ruled in favor of a stem cell clinic in California that a procedure in the office is outside the purview of the FDA.
Okay.
So if you got an adipose tissue collection and they isolated out your stem cells from your own fat, which is very easy to do and very effective to do, and it doesn't require the bone marrow puncture that's so painful and everybody doesn't want to do it. So much easier to do the adipose collection. Isolate the stem cells out and treat the patient with their own stem cells. That is not putting a product on the market. That is not, the FDA is not overseeing a medical procedure in the practice.
Interesting. Okay.
Right. And so, because the doctor is not selling stem cells, they are selling service,
right? Which
is what they do. And the patient is electing for a service at their own risk. It is not an FDA oversight treatment. So that's great. The win for the stem cell industry,
right?
But only certain doctors were even doing that, right? There's only a handful of offices around the country that are actually doing all those. There's more now, because before the FDA was tapping on the door for everyone doing that. So a lot of people weren't scaling that up; they're scaling it down. The FDA is about to regulate out adipose stem cell treatments, so it's going to be the end of that. Well, that was what they're thinking 3 or 4 years ago. Now it's like wide open now, so everybody can go right back into that. So there's a lot of doctors now offering adipose stem cell treatments. So the next level for that, though, is that a patient who wants to, anyone, you could have your own materials stored and banked, cryo-stored, like I mentioned earlier. So you could have your adipose collected. You could send it to the lab. You could have it isolated, get the stem cells out of it. You can have those stem cells cultured, expanded, and grown. Right. And then have them banked in a cryobank right there. And they are yours. You can make 20, 40, 50, 80 vials of amazingly perfect mesenchymal stem cells that belong exactly to you, that are your own cells. It's not someone else's. They're yours.
They're yours, right.
You own them the rest of your life, and you have cell stock now, so you can regrow as much as you want.
That's cool too.
You could grow out thousands of vials before you would ever reach your limit on viabilities, right?
Yeah.
Maybe even tens of thousands before you ever reach your limit on viabilities. So for effective usage. So stem cells for life. And this is what I tell people: one procedure and stem cells for life, right?
Yeah.
And now you can talk to any doctor who's willing to do the treatment on you, because the doctor is not selling stem cells. They don't sell anything. They are performing an injection for you, performing an IV for you, at your own risk and own discretion. You sign the forms that they have, and the patient provides their own property to be
Right.
injected. It's their own stem cells. They own it themselves. The doctor doesn't own it and has no.
Which is great. That's
The doctor has absolutely no say or ownership in your own stem cells, except for when you bring it to their office and they inject it in you, right? So there you go. So that's what I promote now. That is being done by doctors around the country in select doctors.
Yeah.
It's not very widely promoted because everybody's still kind of uncertain if that whole model will last or if somebody's going to step in on that one too. And, but that win, the federal court win
huge.
actually does change the game a bit because there's some precedent to lean on that says that, what the doctor and the patient are engaging in right here is just a service performed by the doctor.
Yeah.
The doctor's not selling stem cells, right? To the patient. So
no, it's a service. Like you said, it's a service. They're providing a service.
There's no product that enters the market,
right?
Nothing like that. So as long as the doctor is willing to perform the treatment, which and I've talked to a lot of doctors about this scenario. Would you be willing, doctor, to perform injections on patients and even intricate treatments on patients using their own stem cells if they own the stem cells themselves and brought them to you, right? Oh yeah, absolutely.
Okay.
If they sign my consent form, I'm fine with that because I'm not selling them anything.
Right.
I'm not selling them any product. I don't have any
liability.
Right.
There's no liability there. You're just, as long as you stick the needle in the right spot.
Yeah. I'll use an ultrasound guided injection and I'm good, Yeah. Or you want to do an IV, that's great. I'll do it. And technically the IVs are supposed to be off limits, but if a patient wants to get it done, the doctor can do it.
Yeah.
Right. Because you're not providing an IV full of purchased stem cells from some company.
Right.
So the FDA is not overseeing that patient's property. Right. You could do this right now with blood banking. You could have your own blood harvested, bank it yourself, have it re-injected into you, and all of that without the FDA's oversight. Right.
Yeah.
So
just ask Lance Armstrong.
Let's ask him. Yeah, he knows all about it. Right. So there's a bunch of people who know about that. And so you can do that. You can have, all sorts of other, you can have anything you want. So, you're a private citizen, so you can pay a lab to do whatever you want. Anything that they'd be willing to do.
Right.
Right. So, but that's an interesting concept. I was talking to a doctor this morning who had not heard of this yet and is in the regenerative space. And he was blown away and completely on board. He was like, "Oh my gosh, I absolutely see what you're talking about. That is completely, in my opinion, that's completely compliant with the standards in play right now, and it's completely ethical."
Yeah,
he's like, I think that's wonderful.
And the benefit, and again, because I kind of want to bring it back down a little bit to what's in it for me. So what will those stem cells be used for? Like, why would you want to do that?
So let's say you want to live forever.
Yeah. I'm all for, I don't want to live. No. You want to live forever. Sorry, Queen. Sorry, Freddie.
Forever young.
Let's see. You're going a different direction.
I was thinking Napoleon Dynamite. Anyways, so
I must be older than you.
No. So any point in the future that you develop arthritis, you can have a joint injection of your own stem cells.
Okay.
They would be very bioactive. They'd be very accepted by your tissues because they recognize each other.
Right. They're
yours. Right. And they're concentrated. They have also been stimulated in a lab to undergo replication cycles. So they're in a state of active replication when they are frozen and stored. So when they're re-injected, they're way more active and
that's cool.
They're acting way more youthful than they were when sitting in your tissue doing nothing. So they're just reactivated, and there's no intention to make them reactivated. It's just that in the replication cycle they become more bioactive.
Gotcha.
So that's happening.
So joint health,
any sort of tissue damage.
Like you mentioned, like an IV. Like, why would you want to pump them into your blood?
So it's funny. I'm actually I've got a book right now that is probably a week away from being published called "Stem Cells for COPD," for chronic emphysema.
Yeah.
So it is when you do an IV, you've got your blood goes everywhere. Mm-hmm. So if you have a high enough dose of stem cells, you'll be able to get some cells
everywhere
to most places that the blood's going. So any tissue damage you have in peripheral areas of your body, older decaying things, get a little boost of active stem cells.
Does that include your brain, by the way?
Well,
I know that's a little tricky.
A blood-brain barrier.
Yeah.
There are some, you could probably find some doctors willing to do some stuff. I don't know of any personally who would be willing to inject anything like that into the into the CNS. But possibly, I mean, it possibly could do that. I know some doctors were, and they still do it. Some of them do. They'll inject into the back of your mouth, the palate.
The soft palate.
It's in the palate. There's a direct. It's a very, very close path to the brain.
Okay.
And you can inject into that tissue, and then it will absorb into the CNS.
Okay.
To that model. They've done that. I had to get on to a doctor about that once because she was doing that with our product at the time, and I was like, it is definitely not
meant for that.
And she was like, well, I've done this, a dozen times. I'm like, well, you have to tell me right now on the phone that you're going to stop that, or I will have to stop selling your product because we can't be involved in that.
Yeah.
She's like, oh, okay. Well, I'll use this other company's product for it. I was like, sounds great. I was like, I'm going to document this call and let everybody know that, we talked and you're not doing it anymore. So,
right.
And you can still buy stuff. That was years ago. But she never had any problems though with patients. So, but yeah, so could be for brain health and all that. But ultimately, a lot of the research I've found is that your capillary beds, right, in your lungs, right? Breathing and oxygen, very strategically key for health and longevity.
For sure.
Some of the research in history has shown that people who had better oxygenation have been able to overcome very significant, problems. There's some studies. You ever heard of the Spanish flu?
Yeah.
Studies
still floating around.
Still floating out there. Yeah. Studies using a technique called rib raising. It's an osteopathic technique. I learned that in school actually. In DO school. DO school and MDs and DOs are equivalent in the medical field unless you ask one of them. Then they'll tell you that the other one is not the same. Yeah. So if you ask anybody else who's not an MD or DO, are they equivalent? Most people have never heard of a DO.
Right.
And the next one of them say that, that DO must be some sort of specialized chiropractor.
Right.
I'm like, well, no, the world of chiropractic kind of developed, from the world of DO, so you can subspecialize in just doing manipulations and not, be a medical provider.
Yeah.
And be a chiropractor. So that's different. But we learned a lot of manipulation techniques. So one of the histories there is that in the Spanish flu, there's a technique called rib raising where you actually have a patient lay on their back and you pull up and out on 2 or 3 rib segments at a time and hold it for maybe a couple minutes.
Oh, wow.
And the tissue initially tries to lock up.
Yeah.
Right? That's the whole I
don't like this.
The concept of a relaxed person versus a tight person in a car wreck.
Yeah.
The person who's bolted to the
They're
car,
the ones that get hurt.
going to get broken, right?
Yeah.
The one who's been drunk is the one who's not going to get hurt, right? Because they're all lax and their muscles are not flexing. Same thing here. You pull up and out on these ribs. It immediately tightens, tries to stop the occurrence, and then after a while it lets go and it releases, and then it stretches. So that's the only actual way to stretch and expand your lung capacity is to do this.
No kidding.
Yeah. Any of these other like lung stretching devices, all they do is diaphragm work. It's muscles and contraction stuff.
Right.
To actually increase your lung cage, increase your lung capacity,
you have to have a bigger instrument.
Space, right? You need more space is what you need. So you need to actually stretch it out. So they were doing this technique to try and increase lung capacity, and it worked. There's an actual research publication on the number of patients who survived the Spanish flu who had a DO doctor performing rib raising techniques on them, and it's like a 20 or 25% difference.
Wow.
It's like 25%. If you went to an MD versus a DO, you're 25% more likely to survive if you went to a DO
because of this technique.
Because of that technique. And it was specifically because, and I'm just estimating the numbers again, it was a 20-something% difference.
Right.
And I forgot exactly how, but it was because of the oxygenation. That's all it was. That technique did not do anything to the actual, virus or the fever.
Right.
All it did was increase the ability to oxygenate. So going back to the stem cells, we have continued detriment in our tissues as we age, deterioration, and our lungs are prevalent to that. They will deteriorate over time. I took a deep breath just because of that. They're becoming less and less effective and whatnot, and so you get this IV of stem cells, and research shows that a lot of cells are caught up in the capillary beds where they could potentially do the most good of the entire process.
Yeah.
Revitalizing and regenerating and retensioning, if you will.
Yeah.
All of the lung tissue that's there, creating your capacity to breathe enhancing your capacity to oxygenate and breathe. So that could be one of the major benefits of doing it. An IV and a stem cell IV is probably oxygenation. Right. So could be that. But then of course, after those capillary beds, all the cells passing through are then distributed in the arteries out, because you do an IV into the veins, right? First. And then, so the arteries are the ones going to the tissue. So that's where you want stem cells. So then all the arteries going to the damaged tissue will have some cells in them, theoretically producing some benefit. So the idea is to get a large enough dose in your IV to produce enough cells on the other side of the lungs, to get, stem cells in the deteriorated tissues. So, but in the meantime, your lungs will be completely super amazing, super lungs, right? Because every time you do this IV, you're revitalizing your lungs. So the longevity concept of doing stem cell therapy is to get routine IVs once or twice a year to revitalize, regenerate all of your tissues.
Cool idea. Yeah.
And you can do that with your own stem cells for the rest of your life, because you're going to live to be 150 if you do that, right? You're doing 2 IVs a year,
right?
You're revitalizing everything, and you're reducing all of your health issues, So, I mean, I'm just joking, 120, 150, but you have this.
Could you imagine though? I mean, and this is kind of sci-fi, but if you could like pass those stem cells down to your kids, they're probably almost as compatible to,
close. You could pass them to a sibling. But you're only 50% related to a kid.
That's true. That's true.
So they very well could reject.
Could have a problem.
Exactly. So, and this is another thing. Most people don't know this. The reason birth tissue stem cells are even a thing is because of the relationship between a mother and a growing fetus. That's so. Why else would it? No one ever asks that question unless they are in the market with me. They're like, and I've had 1,000 doctors ask me this question.
That's fascinating.
Well, how is it that the cell? How come there's no donor
rejection?
The graft versus host. How come there's no graft versus host issues with this?
Yeah.
I'm like, or how is it that you're not having a blood type?
Right.
And I'm like, well, if you're using blood stem cells, you do. So like cord blood, you feel, for some reason, people like the term cord blood. I was on the phone with a doctor the other day, and he kept saying cord blood. I was like, no, I'd like you, just for future reference, when you're talking to other doctors and to patients, you're talking about cord blood, you're referencing the whole category of birth tissues. You need to be careful, because cord blood is probably the least used of all of those, right? It does not reflect all the different tissues. Cord blood is still blood type.
That is so fascinating.
It's still a blood type issue. You're still going to have to blood type with a donor for cord blood. Right. And it's got different kinds of stem cells in it and whatnot, but that blood's got immune markers on it. So you still have to deal with that. But the tissue, the placenta is developed and grown to be the barrier between the mother and the fetus, because otherwise they would kill each other. Right. And you don't want that to happen until they're teenagers. Right. So they wait at least until they're 12 years old before they kill each other. Right. So the mother and the fetus are separated genetically by the placenta. And so on the child half of the placenta, you got, all the child's DNA and biology, and it does not interact with the mom. Right. And it interacts with the placenta, who it acts as a barrier between all of that. Right.
That's just freaking awesome.
But seriously, to do that, you cannot have immune markers on that material. Right. So the entire encapsulation process of a fetus cannot have immune markers on the cell surface, or the mom's body would recognize and kill it. Yeah. Right. And that is a problem when you have accidental bleeds between the two, and the mom's body becomes aware of a fetus, of an alien life growing inside of her. Yeah. Right. And she will potentially have interaction, and that is called a ROGAM shot. Right. You get a ROGAM shot if the blood type differences are off. Right. And there's a risk of the mom's, body interacting with the child and damaging them, fighting them. ROGAM shot. Right. But that material, that amniotic membrane that encapsulates the whole process, the amniotic fluid, the cord, the tissue, all that stuff is immune marker privileged cells. Right. So they do not have immune markers on them, or they do have so few that they can't be perceived by another cell. So you can take those and harvest those out and you can inject them into anyone because nobody's system will recognize them.
Right.
Right. They're the O positive or they're the O negatives
of the
stem cell world. Right. So anybody could take them. Right. And that's what's so valuable about them. And that's why they were brought to market, is because they did not have an interaction capacity.
Yeah.
Right. My companies combined have produced 30,000 plus doses of treatment for the ones that I used to own, for all of these potential treatments there. We've never had a single adverse event occur, but we've had tremendous outcomes across the board for tons of different uses for the product. And we don't make them anymore because the FDA's regulations now, so we don't make any of the birth tissues products anymore. That's why I promote now, if you're going to do stem cells now, just do it.
Do
your own, do autologous, bypass all these FDA regulations, have your own cells harvested, cultured, expanded, and grown, store them in the lab for the rest of your life.
Well, and there's a couple things that I want to get to before we finish up. But just like if somebody wanted to do that, what would it cost somebody to, have that done?
It's not exactly cheap.
Sure.
But it kind of is. So the company that I promote is called LongevityStemCells.com. And the minimum package for that, and again, I could probably get a promotion of some sort for people if they were interested. Just let me know. But standard minimum package for that is $12,000 to produce 20 vials of 10 million cells per vial will be the outcome. Then, and that comes with, that would include the collection procedure from a certified a plastic surgeon who can do the actual adipose collection. A lot of doctors are trained for that kind of stuff, but plastic surgeons can do it in their sleep.
Right.
So, so you just go to them and they can make it really easy. But we have arrangements with them. And so we include that in the cost, in the package. That includes the tissue processing in the lab, the isolation, culture, and expansion out to 20 vials.
Right.
You can get the cost of getting more vials. It's more affordable per vial. So effectively at $12,000, you're buying a vial for $600 per vial, right? To put it in perspective, the value proposition here is, $12,000 is kind of pennies compared to what this would cost to get the equivalent amount of stem cells in birth tissues doing it that way. Remember, if I have a vial of 10 million cells from any birth tissue, I don't have 10 million stem cells. I have 10 million somethings.
Right.
With a few 100,000 maybe stem cells, right? And most of them may not even be viable, right? I haven't seen a lab yet be able to take an over-the-counter birth tissue product and culture and grow that. Like they just can't, right? So not very viable. Birth tissue stuff works great for regular use and stuff like that. But imagine if that vial with a few 100,000 something stem cells maybe costs you $1,500, $2,000, what it used to cost. Maybe you can get a 2 cc vial of that for $1,000 now. I mean, maybe if you can find it at all.
Right.
But the vial you just created in the lab has 10 million pure, isolated, cultured, expanded mesenchymal stem cells that belong to you, and they're probably 98, 99% viable. Every single one of them. So the value proposition between that one and this one, and for this one over here to still cost more than yours did per vial, right? The only investment you have to make is you got to buy at least like 20 at a time.
Right.
So one of the things I've talked to the lab about, what if people want to do this, but they don't want to pay so much and have 20 vials made? They're like, well, we're already there.
Right.
Like we're already making it. It's not going to be worth it.
Right. It's like the t-shirt company, it's $100 for one. It's, $102 for 50.
Yeah, exactly. Like we've just processed it. We just isolated it. If you only want to do that and store it, then if we were to take that and go back out and then reculture it, you're going to pay more than the difference between the other one. So like, it's just do it. So like the next package goes up and you got, like 40 vials, 60 vials, 80 vials. And at the 80 vial mark, I think that one's like 24,000 for that package. We got 80 vials. Yeah. And that 80 vials is equivalent to what, $300 a vial, right? And they're good for life. I mean, they're in cryo
and again,
storage.
it's the pure stuff.
It is, yeah. It is. So the value proposition is completely different. From an over the counter anything. So if someone was going to make the investment, and by the way, so say somebody did do the smaller one and they ran out after a few years of using them, they could actually have their stock, because there's a couple of stock vials stored, because they don't need to use all your cells to replicate out those 20. They'll use some of them to replicate out the 20 vials. The other ones they'll keep as stock cells for you in the future, so they can actually replicate out. Like I said, at
another
the end of the
20.
day, at the end of the day, we could do hundreds and hundreds of vials, maybe even thousands of vials you probably would never ever use that many. Even if you lived to 150, you probably never use 2,000 or 3,000 vials.
Right. I mean, if you're doing, even 1 or 2 a year, you're looking at 300.
Yep. Yeah, exactly. Yeah. So, I mean, exactly. So it's, you're not going to use that many, but you could if you wanted to. But that being said, it's still way cheaper than if you were to try and buy it through the lab production method.
And think about, the benefits, versus, limping the rest of your life, having, maybe in some cases having to have a limb removed, in some cases possibly, not being able to breathe properly. I mean, all of these things, like what's the value of that?
I mean, look, it's hard to put a value on that. I've talked to so many patients who avoided surgeries because they got regen treatments done. Some of these treatments can keep people out of problems for years and years and years. And if you can get regular treatments done for that, you can keep it gone. Right.
Yeah.
I have a doctor that did injections in his own knees, and he was in chronic pain with osteoarthritis. He did a single injection himself, actually, just like, performing your own surgery.
Right.
I'm like, whoa, dude, that's really cool. He's like, I did my own injections in his knees. He did that. This is, call it 2017.
Okay.
And maybe 2018, whatever. He still reached out to me about 8 months ago, 6 months ago, to let me know they still work.
Oh, wow.
So he had, he was blown away after the first 6 months of being out of pain. He's like, I don't know how this works. He's like, I'm back in action. I'm doing stuff. I'm going. And this, by the way, these products that we use were pure amniotic fluid. They weren't stem cells, just pure amniotic fluid. He's like, I don't know what happened. Like, I'm out of pain. I don't take pain meds anymore. I'm out and doing stuff. The only thing that happens if I overdo myself, they'll be sore for maybe a day or 2, and they're back to normal, being healthy and not sore anymore.
Like you're supposed to
the
be.
Opposite of the opposite of what it used to be, where it was sore and in pain all the time.
Right.
And he had days where it wasn't, and most days it was.
Yeah.
But he said, I can't believe it. So a year went by. He called me. He's like, I'm just calling you to let you know. Like, I don't have anything to say other than I can't believe this. Year later, they called me during COVID a couple times. He was all like, I'm just like, I can't do much with anybody else, but I'm outside playing. And he was like, my knees are still good. And he's an example of why doctors don't like this. Other doctors don't like it because he didn't need anything else.
Right.
One treatment for him lasted him probably, I don't know if it's still going, but lasted him 4 or 5 years.
That's insane.
Right?
That's awesome.
So he avoided all the medications, all the injection procedures he would have got with steroids, all the knee replacements. Put it off at least.
And like for me, one of the things I think about is if you're able to get an infusion of something, like if you're able to get something that helps you for the right person, it will immediately help them be more healthy. Like if I'm hurting all the time, I'm not exercising.
Right.
I'm not eating right.
It's the chronic pain cycle. It's the downward cycle.
So if you can break that, if you can scratch that record and be like, okay, I can be done with that even for, a month where you're feeling good, and all of a sudden you're getting into these good habits all of a sudden, and you're feeling good doing those, like those things compound on top of each other, and of course your body's going to respond well to that.
Yep, absolutely. You feel better. You're not in pain. You can be more active. That is the upward cycle.
And I have to say, like, even just the emotional, mental health of that, the absolute, having had times in my life where I've been in chronic pain, like the agony is so wearing.
Oh yeah.
So just having the mental clarity of being able to like think and being able to you can't put a price on that kind of stuff.
No, you can't. I mean, it's your life. It's your whole life.
Yeah.
It's like, can you put a price on how valuable it is to have your actual life?
Yeah.
Well, being alive and being alive are different things, right?
Right. Exactly.
So, it's like, so it's hard to say, but then again, I mean, I've seen it. There's actually a pretty strong push to have behavioral health integrated into pain management.
Yeah.
In the standard medical field, just because most patients with chronic pain are experiencing
depression,
major
sure.
Depression and anxiety daily. Getting on those meds.
Just
and all that
even, and again, like I totally understand somebody who's like, if this is going to be the rest of my life, do I want it to be the rest of, like, how long do I want this to happen?
Yep.
And that becomes a real troubling thing. And it becomes so if you can, this is why I have no problem with people sometimes doing exotic and strange things to try to help them, you know, like for example, you know, I know there are lots of, you know, all these drugs have got consequences and side effects and such, but like stuff like Ozempic and stuff like that, you know, like I get it. Like there can be some really harmful stuff, but like, what's the trade-off? You know?
Yeah, that's actually what they, literally how they calculate the cost benefit, you know, of some of these drugs is the side effects may be fairly bad, but the thing we're trying to stop is worse.
Right.
So we'll just go with this.
Or even, and unfortunately, sometimes it's perceivably worse.
Yeah.
But that's where, like, if you could find a treatment that's more natural,
right.
Find a treatment that, you know, doesn't have the side effects. Find something that's going to allow you to do the things that you want. Like, I would much rather feel good and lose weight by exercising and eating right than having a drug kind of force my system upon it.
Exactly. Yeah, no, exactly right. I mean, everybody else is thinking the same thing. It's just that, like I said, medicine is a very large ship. It takes a very long time for that to turn. But there are great things available, unfortunately, for cash pay.
Yeah.
But they are available. And some people are doing it and having amazing outcomes and results. Some of the best treatments out there are being had by people that have enough money to pay for it.
Right.
Because some of these things are expensive.
But you know what? Here's what I love about your philosophy that you've always had is that from, you know, having you on, like you have to make money. We understand that you have to, but you also have to bring it in a way that's accessible, you know? And I think, you know, and there's different levels of accessibility. Like not everybody can throw down 12 grand for a stem cell, you know, bank, you know, but maybe there's some other things. And, you know, if I've talked about some ideas that you can kind of like, you know, dip your toe in the water.
Yeah.
You
well,
know?
okay. So remember we're talking about exosomes.
Yeah.
Right. So I talked to you the other day.
Yeah.
I mentioned I had a product line that I had started. It's topical.
Okay.
So in the world of exosomes and regen med, topical things have been allowable, like for aesthetics, you know, skincare, things like that.
Right.
And most of those things have been done in the form of procedures. You've heard of a vampire facelift,
right?
Or vampire facial, where it's a PRP. That's what I mentioned earlier. They take your blood, spin it down, get the PRP out. Then they use microneedling and they abrasively, you know, chew up your face a bit with needles.
Right.
And then they rub PRP all over it, and it grows back nicely.
It grows back right.
It grows back beautifully, right?
Yeah.
It's better than a chemical peel and all that stuff. And it does work really, really well. Well, back in 2017, I was working on making some facial kits for med spas to do that without having to do a PRP. So no blood draw, because patients hate that.
Yeah.
You know, but you can just use a vial of our product that we made in the lab. Well, I tried to get that out in the market. Didn't really get it that way. I was still in the pain management world back then. But I patented some of my formulas for direct to consumer topical use, right? Because I'm like, well, we don't have to go through a doctor's office to sell something with exosomes in it if it's for topical use and it's not in a format that could be manipulated or abused. Like, you know, if you can't put it into an injection,
right,
without hurting yourself, you know?
Yeah,
so
yeah.
no one can screw that up, right? So it's just a topical, apply it with your fingers type of thing, you know, for your skin, and it can be used that way. And so I years later finally got that underway. I have it now. I mentioned earlier Regen Aesthetics.com.
Yeah.
That's the site for that, and I have that product line out. So I've got a lash serum, a brow serum, facial serum. Got a facial cream to complement the facial serum. I have a hair serum, and again, we're talking about a serum that is designed to allow the exosomes, and it's got exosomes in it. That's what's in it, right? That's the second ingredient for a lot of stuff in there is exosome fluid.
Okay.
To get into the actual skin and trigger the regeneration effects of skin and tissue, trigger the regeneration effects of hair, lash and brow. That's been somewhat of a remarkable product already for people. We had people that have just come back and said, "Oh my gosh, like I could not believe this." And there's a pharmaceutical product called Latisse, and I've had people tell me that ours was working better
Wow.
than Latisse, but it's not a pharmaceutical and doesn't have side effects.
Right.
You know, now that's just anecdotal. I don't know how many real evidence. Sorry, Latisse, I don't know, but like, I'm sure your product is amazing. But I do know their product's expensive, and it has to be like prescribed.
Yeah.
Ours doesn't have to be prescribed. It's just biologic. So, but yeah, and the hair serum, I've heard that one works really, really well if you have the right kind of hair loss. If you have some true health issue hair loss, it's not going to help that.
Right.
But if you have just genuine, thinning,
Pattern balding,
it's typical alopecia that could be reversed from regular treatments, or whatever, then this could work in those cases. Facial serum's great, but the cool one the one I actually patented years ago was it's an exosome sugar scrub.
Okay.
So you take sugar and you put basically the early versions of this, literally using just table sugar and pouring a vial of exosomes that I would have normally, or amniotic fluid or exosomes, I tried both, that I would have normally been selling to a doctor's office, pouring it into the sugar, stirring it up till it made a little paste.
Right.
And then just using it on your face and just scrubbing it in really nice and like just abrasing it,
Okay.
And oh my gosh, you'll have glowing, vibrant skin for weeks.
Really?
After weeks, I'm telling you. So I've had people that were trying it. I let people try it, and I'm like, I should have probably gotten some,
compensation for that.
no, some documents signed to protect you.
Oh, yeah. No, that's really pretty rad.
Try it and see what happens. I don't know what's going to happen here. It's like, it should work great, but I tried it myself first. I'll give everybody that, I'll try it myself. And man, my skin was like, I had people saying, that I looked,
young.
Like I was like, like it looked like I had been, like slightly sun-kissed, like I was,
right,
like been out like surfing in the sun.
How cool!
I've had people that had their vibrant facial skin glowing for weeks, and they got compliments. Is
that because obviously the point is that you're re-stimulating your cells. Does that, like, for example, somebody who maybe has acne or something like that, would that be helpful at all? Or you don't know?
It could be. We've not had anybody with skin conditions using it and reporting back that it's healing a condition.
Right.
And we aren't selling anything for conditions. It's all just for general aesthetic use. Like, this will help your skin be more vibrant and healthy, but not treating a condition. I'm sure it would help a condition, but in general,
that is pretty remarkable that, and so I love that idea of like, if you want to like I said, dip your toe in some of these like new, exciting, really cutting edge, healthcare longevity products. And I think it's a, inexpensive way to try it out, and you might see some amazing results.
Yeah, you absolutely could. I tell people that my 3 categories of longevity, aside from all the other health stuff, and the 3 categories are look it, feel it, act it.
Yeah.
Right. People want to look it. They want to look young. They want to act. They want to feel young.
Right.
And that's all of the medical stuff we're talking about that makes them feel younger,
right,
literally feeling better. They want to act young. What good's having all that if you can't actually do stuff, right? So that look it, feel it, act it. Those 3 things together are what people are looking for in longevity. Well, the look it part, I can help with that without having to go through all the compliance and medical and processes and all the stuff like that. Well, that's pretty easy. In general, I could make a product with regenerative properties that can actually help people's skin look better, make them feel younger, help regrow hair. So that's great. And you don't have to use needles for that. So that's the thing. I'm like, what if this hair treatment is actually working better than some of these more invasive needle procedures?
Always better.
I'm all like, yep. Yeah. What if you don't have to do that vampire facial with all the needles and the blood?
Yep.
What if it could just be a serum that you rub on? I got about a half dozen samples of the sugar scrub made in our new formula. Yeah. Right. So we're producing it. It's in production now. I don't have it ready, but all the other stuff's ready. I've got inventory and we're selling. But the sugar scrub, I gave it to select people to try. Yeah. I gave it to this nurse practitioner that I know really, really well. And she was like, oh my gosh. She's all like, I have the best skin I've ever had. She was all like, I'm like, you're only supposed to do it once a week, really, or maybe a couple times a week. She's like, I use it every night. And I was all like, okay. She's like, I need a tub of this stuff. And I'm all like, that's an expensive tub of stuff. I was like, the sugar part's cheap, but the rest of it's expensive, Right. But yeah, so I can't wait to get that one out. I know it will do well because I've actually seen plenty of people firsthand, use it. People that let try it. The other stuff though, I've already had a number of people coming back, and we've only had the product. I finally got the inventory in, first rounds of production made, and only been selling some of these other serums for a number of weeks and like maybe a couple months now. That we got samples in months ago. I gave out the samples.
What's the website again?
Regen Aesthetics.com. It is REGENESTHE. TICS.
And we'll put links all over the place for you to go check it out.
The American aesthetics, not the British aesthetics with an A.
Yeah, right.
We're gonna change the world. It's gonna be E aesthetics. Regen aesthetics, not AE aesthetics, not the Latin diphthong with the AE. So no, it's regenaesthetics.com. But yeah, I'll get you the link, and you can send out to people if you want. But yeah, that's. I
totally encourage people to check it out. I think it'd be
Yeah. So yeah, and also too, any of the if anybody listening has interest in real stem cell treatments, stuff that if they're in the U.S., I know you have listeners all over the world.
Yeah.
We can actually accommodate listeners all over the world. You can actually send your adipose samples from anywhere you live to our lab here and have all that stuff done. So absolutely doable anywhere in the world, and you can come here and get it. You can have your cells shipped to somewhere else in the world. I'm sure there's probably plenty of options if you're international.
Yeah.
You don't need this necessarily, but in the U.S., this is probably the best thing you can do for routine. So you're talking about professional athletes.
Right.
Some of these guys and women, some of these men and women in the professional field are spending hundreds of thousands of dollars a year going overseas for these treatments. Right? They don't have to do that. You don't have to spend that much. You can spend a fraction of that
and have it done right here
in the U.S.
And
they don't know it. And all the doctors you're talking to are referring them out to a center that they probably own some of. They own 1% of it in some Costa Rica or something.
And
like that.
I don't know all the rules, but you're probably going to have less a chance of going past getting having a problem with your union or whatever the league rules are.
Yeah, I mean,
because it's your own stuff.
It's your own stuff. I mean, like you're not blood doping,
right?
I mean, I joked one time. I was like, it's kind of like stem cell doping. It's kind of like performance doping, but it's legal because it's stem cells and it's your own stem cells. I'm all like, but it's not blood doping because that's a direct oxygenation improvement,
right?
And that's why it's illegal, because you can outperform. But this one doesn't do that. I mean, they'll come around at some point,
right?
But to probably regulate it so people can't be amazing performers for 50 years, and you got somebody who's a
we'd hate to see that.
Yeah, I mean, like you got all these these amazing ball players, that are like 50 and 60 years old, normally retire at like 25 and 30, or whatever, and they're like
now we know Tom Brady's
still
secret.
Out there dominating because they're getting like 2 or 3 IVs a year of like 50 million stem cells, and they're back at 25 years old, like bring it on, and I got like 20 or 30 Super Bowls, championships, that'd be hilarious.
That would be pretty hilarious.
And Tom Brady and whoever else, you can do that right here in the U.S. Just give me a call.
Right on.
I know the doctors who will do it for you. I got the lab who will do the expansion for you and the storage for you. You give me a call.
We'll get you guys a direct line.
Yeah, there you go.
Hey, listen, we got to cut this off. I want to keep going though. Let's do it again. We have so many stuff to discuss.
Oh yeah.
So many stuff to discuss.
And I didn't even finish talking about CRISPR and apples.
See?
Now I want a crisp apple.
Right.
Yes. That's what I'm going to now. I'm going to go find a nice crisp apple.
A little honey crisp apple. And yeah, so we've got that to talk about. We've got archaeology to talk about.
Oh my gosh, yes.
We got all kinds of stuff. So we'll do it again.
Okay.
Will, thanks, man.
You're awesome. Thanks.
This has been fun. You're listening to And If Love Remains.
Mike is gone.
You are listening to And If Love Remains.
Gone but not forgotten.
First of 23 installments requested by Dr. Leavitt. Trying to be in compliance here because we're taking him and that whole organization down.
Speak peace like a Buddhist.